In this video we'll learn to count in ones up to 1,000. In a previous video for entry 2 we learned how to count in ones up to 200. The pattern is exactly the same, so I will rejig your memory with this. So numbers here from 1 to 100, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on up to 100. Then 101 was written like this: 101, then 102, 103, 104, 105 and so on. So we did those up to 200. Then would come 201, 202, 203, 204, 205, 206, 207, 208, 209, 210, then 211. So exactly like these numbers, we're just adding the hundreds at the front. So we've got that 2 at the front, where that's 11, that's 211, then would be 212. So we're just showing that there are hundreds and then the tens and the units. So 200 and then 12, 213, 214 and so on. When we reach the 300s, then we start again: 301, 302, 303, up to 400, then 401, 402, 403, then we go to 500, 600, 700, 800, 900, and finally 1,000. So I'll just write a few examples in terms of how to write them and how to read them. So 314, this would be 398, 412, 565, 708, 800, 911, 999, and then finally 1,000. So these are just some examples of how to count up, and the pattern, as we said, is the same. In this video we'll learn to count in twos up to 1,000. To count in twos means to leave a gap and then move on to the next number. So 1, 3, 5, 7, 9, 11. This is counting in twos. Or I could start with 2, then 4, 6, 8, 10, 12 and so on. So you should be able to count in twos up to 1,000. We looked at counting in ones up to 1,000 in a previous video. If you need to recap, go back to that. But the only difference with this is that you leave a gap. So normally you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on. But we don't include those when we count up in thousands. Count up in twos up to 1,000. So you should be prepared to have any starting point and continue that pattern. So if it's 112 and we're counting in twos, then it would be 114, 116, 118, 120. Or if we have 304, then we'd have 306, 308, 310, 312. Or if we start with 499, then the next number would be 500. The next one is 501. Then 502, 503, 504, 505. So the final example, 983, 985, then 987, 989. Then that comes very close to 1,000. So just out of interest, the next one would be 1001. So this is how to count in toes up to 1,000. In this video, we'll learn to count in tens up to 1,000. This is what it means to count in tens. So if we start with 0, then we leave a gap of 9, and then we move to 10, then 20, 30, 40, 50, 60, 70, 80, 90, 100. Then we add another 10 to it, so it'd be 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 230, 240, 250, 260, 270, 280, 290, 300, 310, 320, 330, 340, 350, 360, 370, 380, 390, 400, 410, 420, 430, 440, 450, 460, 470, 480, 490, 500, 510, 520, 530, 540, 550, 560, 570, 580, 590, 600, 610, 620, 630, 640, 650, 660, 670, 680, 690, 700, 710, 720, 730, 740, 750, 760, 770, 780, 797, and that would be 800, 810, 820, 830, 840, 850, 860, 870, 880, 890, 900, 910, 920, 930, 940, 950, 960, 970, 980, 990, and 1,000. So if you look at the patterns, that should help you count and remember. So we've got 10, 110, 210, 310, 410, 510. So all that is changing is the hundreds column. Same thing here, 20, 120, 220, 320, and so on. So this first row is repeating itself in every other row 10, 20, 30, that's 110, 120, 130, 210, 230, 220, 230. So this should help you remember how to count in tens up to 1000. In this video, we'll learn to count in hundreds up to 1000. Counting in hundreds looks like this. So we start with 0, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. So we leave gaps and we count in hundreds. You should be able to start from any point. So if you see a pattern like 300, then you'd fill it with the next one, 400, 500, and so on. This is how you count in hundreds up to 1000. In this video, we learn to read and write numbers up to 1000. In a previous video at entry 2, I've looked at reading and writing numbers up to 100. If you need to recap that, go back and look at that video, because we'll start from 100 here. So the next number up from 100 is 101. So there we have the units, there is just one. Tens, we have no tens in this case, and hundreds, there is just one. So 101. Then we have 212. 745, 468, 610, 809, 999, and the next number up after 999 would be 1000. So we've just read the numbers and we looked at the hundreds, tens and units, which help us read the numbers. Now writing them, so we've got 841. How do I write that? So 841. How do we write 206? 206, because we know we've got units, then tens and the hundreds. So when I say 200 and then 6, that means I need to put a 0 in between, because that's the place for the tens and I haven't got a 10 in this case. So 216 would be written like this. 206 would be written in a very similar way, but just with a 0 in the middle to hold the place of the tens, because if I didn't have that gap, or if I didn't put the 0 in there, I would end up with 26, and that's not 206. So I would cross that out. Let's say 410. So 410, 563, 934. You'd also need to know how to write these numbers up to 1000 in words. So 841 is just one example. So keywords are 100. That you probably didn't know before. So 100, 100, 200. So in front of it you can write 8, 1, 2, 3, 4, 5, numbers that we've seen and looked at before. And of course you need to know your tens, because we've looked at those as well at entry 2. So 10, 20, 30, 40, 50 and so on, how to write those, including 80, which is a bit more tricky, and 40. So we don't write it as 440. That's how you write 4, but 40 is not written like that. It's written without a U. So 40 and 90, because some people confuse this as well. They leave out the E. So that's how we write 90 as well. Try by practicing writing different numbers, the digits and the words, or reading them out from different places, because we find numbers everywhere. In this video, we'll learn to order and compare numbers up to 1000. So I've put down 4 different numbers and I've labelled the units, tens and hundreds to help us. So the first number is 403. Then we got 430, 340, 304. So let's compare some of the numbers. If I compare the first two, 403, so that means I've got 400 and just 3, whereas this is 430, so this is bigger. So right, 430 is greater than or bigger than 403. This means greater than. It's like a crocodile mouth that opens up and it likes to eat the bigger number. So 403 is smaller than 430. And comparing them to 340 is greater than 304, whereas 304 is smaller than 340. So that's how you compare numbers. Or you could compare these two, for example. Okay, 340 is smaller than 430. So we've compared them. Now ordering them, which one would come first? Let's say we order them from the smallest to the biggest. So out of these, I can see that these two have 300s, whereas these have 400s. So that means these are bigger. So I'll start from this side because hundreds are bigger than the tens and the units. So one of these two will be the smallest one. So 300, is it 340 or 304 that is smaller? It is 304 because it has no tens at all. It's just the 4 units. So 304. And then, as we said, there comes 340. Now, is it 403 or 430? 403 is smaller than 430 because it has no tens. So 403, and finally 430. So to compare numbers, we just check them, look at the hundreds, which one has more hundreds, that's going to be bigger than the one that has fewer hundreds. And then you look at the tens, if they are the same, if one has more tens, then that's bigger, like this one here. And then if that is still the same, let's say this was the same, then I'll look at the units. The one that has more units, that is going to be bigger. So between them two, this would be bigger. In this video, we'll learn to add 3-digit numbers. So I've represented here 111. And underneath that, I've got 133. What I'm going to do is I'm going to add these two amounts together. And let's see what amount I get. So I'll start with the units because I might have more than 10 and then I'll need to carry them over. So I've got 1, 2, 3, 4. So 1 and 3 makes 4. And I'll look at the tens now. So I've got 1, 2, 3, 4 of them. And I've got 1, 2 of these. So the number that I get when I add 111 and 133 is 244. So I'll illustrate with another example what I just did, this time using the digits. So let's say I've got 453 and I'm going to add to it 216. So I've got 3 and 6 makes 9. 5 and 1 makes 6. 4 and 2 makes 6. So that is 669. But I want to also look at what happens when we have more than 9 in these columns. So I will add a few more. So I've got, now we've got 100 and 17. So there are 7 and I've got 3 there. So what's that gonna do to the number? 7 and 3 makes 10, and as we've said before, we can't write 10 here, it's just the units that I'd write here, and they go up to 9. So if I have a 10, that would be transferred over here. So I'll write the 0 and I'll add that 10 to this side. So that means I'm actually putting all of these together to make a block of 10. So that means I've got now 1, 2, 3, 4, 5. So I've got 5 10s because I carried over one lot of 10. And the hundreds haven't changed, so I've got 2 hundreds. So that number is now 250. That's what these two added up to. So I'll look now at another example. Let's say we've got 584 and I'm going to add 328 to this. Let's see what we get. So again, we start with the units. We've got 4 and 8. That makes 12. So I'll write the 2 down out of the 12. So 2, that represents the units. And a lot of 10 will be carried over. So I've got an extra lot of 10 in there. So 8 and 1 makes 9. And another 2 makes 11. So again, just like with the 12, I write the unit down and I'll carry over the 10 because that makes a lot of these, which is the hundreds now. So we've got 5 and 1 makes 6 and the 3 makes 9. So that makes 912. We'll now look at another example. So if we have 457, we'll add to it 294. So 7 and 4 makes 11. So I'll write the units down, transfer the 10s over to the 10s. So we've got, right, 1 and 9 makes 10 and the 5 makes 15. So we've got the 5 of the units down, we transfer those 10s over. So 1 and 4 makes 5 and the 2 makes 7. So that makes 751. The method that I've just used to go through these is called the column method. So now that we've looked at the column method, we'll look at a couple of other methods. The next one will be the partitioning method. So we'll break the numbers down into parts. Let's say we've got 213 and we'll add to it 445. 213, we'll break it down into 200, 10 and 3. 445 will be 400, 40 and 5. Let's collect the hundreds together. So we've got 200 and 400 makes 600. 10 and 40 makes 50. 3 and 5 makes 8. And another example, let's say we've got this one here, 453, and we'll add 216. So that's broken down into 453, then we have 200, 10 and 6. 400 and 200 makes 600. 50 and 10 makes 60. 3 and 6 makes 9. So our answer is 669, just like this was 658. So that illustrates how to use the partition method. We'll now look at the number line method. So this is how that looks like. Number line method. So let's have 584 as the starting point. What we're going to do is we're going to add to this 328, which is broken down into 320 and 8. So I'll add these in turn. 584. If I add 300 to it, it will become 684, 784, 884. So 884. So I've done the 300. Then I'm going to add 20 to it. So 884, 894, and if I add another 10, that will become 904. Now all that remains is adding 8, so I'll add 8 to that. If I add 8 to 4, that becomes 12, and that was 904, so this is 912 as the answer. In this video we'll learn to subtract 3-digit numbers. I've represented 135 using the cubes. What I'm going to do is take away 23 from this. So we start with the units, because in this way we will know whether we need to borrow from the tens, and we'll look at examples to illustrate this. So we've got 5, I need to take away 3. So once I take away 3, what I'm left with is 2. There we have it. Now we have 3 tens. If I take away 2, I'm left with 1. And I've got 100, but there aren't any in the number, so I don't need to take any away. So 1 take away 0 leaves me with 1. So the answer is 112. Let's have a look at another example now. So this time around I will have the same number to begin with, so 135. This time I will take away 48. So now I've got 5 units, but I need to take away 8, which is not possible. So what I'm going to be doing is borrowing one of the tens. So this now has become 10, 11, 12, 13, 14, 15. Now it's easy for me to take away 8. So I'll take away 8, and that leaves me with the 2 and the 5, which makes 7. Now those 3 that we had here have become 2. So I've got 2, I need to take away 4 from it. So I can't really do that. For that reason, I borrow a lot of the hundreds, which makes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens, and the 2 makes 12. So it was 2, it has become 12. Now 12, I can take away 4. I'll take these 2 away and another 2. So that leaves me with 8 now. So my answer is 87. So let's see again. I'll rewrite the number to see what exactly happened there. So the number that we had was 135. So I tried to take away 8 from the 5, but it wasn't possible, so I needed to borrow a lot of 10 from the 3. So I borrowed 1, the 3 became a 2, and since it's a lot of 10, that made this 5 a 15, because a lot of 10 is worth 10 single cubes. So that became 15. I take away 8 from it, which leaves me with just 7. Now the 10, so we've got just 2 10s in here, and I need to take away 4 of them. So again, I can't do that, so I'm going to borrow 1 from the hundreds. So that gave us 10 10s, and altogether that was 12 now. 12 take away 4 gives me 8. That one there became a 0, so I've got nothing left in terms of hundreds. So my answer is 87. Let's have a look at a couple more examples. So this time around I will do 534 take away 296. Let's start with the units, because as you can see I will need to borrow. The 6 taken away from the 4 we can't do, so I'm going to have to borrow 1 from the 3, make that a 2, and the 4 becomes 14. So 14 take away 6 leaves me with 8. Now we have 2 taking away 9, which is not possible, so I'm gonna be borrowing 1 from the 5 to make this a 12, and the 5 becomes a 4. So now 12 take away 9 gives me 3, 4 take away 2 leaves me with 2. So my answer is 238. How can I check that I've done it right? I will do the reverse. So I'll get 238, add 296 to see if it adds up to 534. 8 and 6 give me 14, so 4 down and 1 carried over. 1 and 9 is 10, and the 3 is 13. So we've got 2 and 2, and the 1 makes 534, and that's what I had. Let's do just one more subtraction. So we'll do 547 take away 498. So again, need to take away 8 from the 7, which we can't do without going to negative numbers. So I will borrow 1 from the 4 to make it a 3, so the 7 becomes a 17. 17 take away 8 will actually give me 9. So now I'm left with the 3, and I need to take away 9 from the 3. So again, I'll need to borrow. So that becomes 4, 13. Take away 9 leaves me with 4. 4 take away 4 is 0. So that is 49, the answer. Let's check that we've got it right. So we'll add 49 and 498. 9 and 8 is 17. 1 carried over. 9 and 1 is 10, and the 4 is 14. We'll carry 1 over. 4 and 1 is 5. 547. That was what we had to begin with. This method that I have shared, we call it this column method. Now we'll subtract 3-digit numbers using 2 other methods, the partitioning method and the number line method. Partitioning means breaking down the number into parts. So I'm going to break down 239 into 200, 30 and 9, and 128 will be broken down into 100, 20 and 8. Now 200 take away 100 leaves me with 100. 30 take away 20 leaves me with 10. 9 take away 8 leaves me with 1. So the answer is 111. When it comes to numbers that you have to take away and you've got to borrow, then this method becomes more complicated. So I wouldn't encourage you to use this method when you have to borrow. With the number line though, you can do borrowing as well. So if you remember, when we did addition, we started off with a number here and then we added as we moved on. Since this is subtraction, I'll start with the total being here, 425, and I'll take away 247, which means taking away 200, taking away 40 and 7. So you could start whichever you want to take away with. I'll start with 200, so I'll take away 200. So 425, 325, 225. Now I will take away 40, so I'll go 215, 205, 195, 185. And finally taking away 7, so 185. I'll take away 5 first to make this 180, take away another 2 to make this 178. So my final answer is 178. And this is an easy way to work out, but it depends on which one you prefer. So you stick to the one that you really like and can use. In this video we'll learn to divide 3-digit by 1-digit numbers. So I've created here and represented 252. I'm going to divide this number by 2. So what does that mean? Dividing by 2 means halving, but also means how many 2's fit into the number. So I'll try and make lots of 2 with the hundreds first. Can I make a lot of 2 with 2? Yes, I can. So there is one lot of 2 here and there is nothing remaining. So I've made one lot. Now I'll try and fit 2's into the 5. Can I make any lots of them? And I can make 1, 2. So I'll make 1 and another lot. So that's 2 lots, but I have 1 remaining. So I'll write 2 lots and there is 1 remaining. So I'll transfer that to the 2. The units. So now that has become 10 and 2, 12. So how many 2's fit into 12? if you try and break it down, we get 1, 2, 3, 4, 5, 6, exactly 6 of them. So that is 6. So the number that we had, which was 252, when we divided it by 2, that gave us 126. How did that happen? What did we do? We tried to fit 2 into 2. So that is one lot of it, because 1 times 2 makes 2, and there was nothing remaining. Now, how many 2's would fit into 5? And that was 2 of them, because 2 times 2 makes 4. So there is 1 remaining out of the 5. Now that has become 12. So how many 2's fit into 12? That was exactly 6. And if you check it, 126 and 126, so 2 lots of them make 12, 4, 5, and that is 2, so 252. That shows that we've done this correctly. Now let's try and do some more examples of division. So we'll do 468 divided by 4. We'll try and fit 4's into 4. That is one of them. And there is nothing remaining. How many 4's fit into 6? That's just 1, but there are 2 remaining. So now 4's into 28, and that is 7 of them. Finally, there isn't anything remaining. So 468 divided by 4 gives 117. Now we'll try another one. 574 divided by 4. So how many 4's fit into 5? That is 1, and there is 1 remaining. How many 4's into 17? That is 4. So 4 times 4 is 16, and that leaves us with 1 remaining. How many 4's into 14? That is 3, because 3 times 4 makes 12, but there are 2 remaining, so remaining 2. So this shows how to divide 3-digit numbers by 1-digit numbers. We'll now look at dividing 3-digit by 2-digit numbers. So I will take a number 136. We'll try and divide that by 12. So just like with the 1-digit numbers, we'll try and fit 12 into 13. How many 12 fit into 13? That's just one of them, and there is 1 remaining. So now we'll try and fit 12 into 16, and there is just one of them fitting. So that makes 1, but there are 4 remaining, so 11 remaining 4 is the answer. Now let's try another one. So we have 486. We'll try and divide this by 24. So how many 24's fit into 48? That is 24 and 24 makes 48. So there are 2 of them. There is nothing remaining. We'll try and fit 24 into 6, and it doesn't. So that makes, then we'll write that 0 down, and there will be 6 remaining. So 20 remaining 6. Now let's try another one. So we'll have 273 divided by 13. So how many 13s fit into 27? Let's have a look. 13 and 13 makes 26, so there are 2 of them, and there is 1 remaining. So 13s into 13, there is just 1, and there isn't anything remaining, so the answer is 13. The answer is 21. So 273 divided by 13 makes 21. And this illustrates how to divide 3-digit by 2-digit numbers. And we'll now look at some real-life examples. Anne needs to make 250 cupcakes for a party. She wants to know how many trays she will need. Each tray makes 12 cupcakes. How many trays will she need? So she needs to make 250 cupcakes in total, and 12 fit in each tray. So we'll divide 250 by 12. So we'll find out how many 12s fit into 25. And 12 and 12 makes 24, so it's 2 of them. There is 1 remaining. So 12 into 10, they don't fit, so we'll write 0. So we've got 20 remaining 10, so 10 cupcakes remain. Now the question is, how many trays will she need? If she used only 20 trays, she will only be able to make 240 cupcakes, but she of course needs to make those 10 extra cupcakes as well. So we can't say she needs 20, we'll say she needs 21 trays. There'll be 2 spaces left, but we can't leave those 10 out, so we'll say 21 trays. Now we've got Surinder takes the train to work. Each ticket she books costs £15. She has £184 in her pocket. How many tickets can she get with this amount of money? So she has 184, and 1 ticket costs £15. So we'll divide 184 by 15 to find out how many tickets. How many 15s fit into 18? That is just 1, and there is 3 remaining. So 15s into 34, 15 and 15 makes 30. So we'll write 2, and that's 4 remaining. So she can buy 12 tickets, although she has 4 more pounds left, because this was pounds, 184 pounds, so there are 4 remaining, 4 pounds remaining. Now with 4 pounds she can't get an extra ticket, so we'll just say 12 tickets, and we know that this 4 means 4 pounds. So this is how to interpret the remainders when it comes to division. In this video we'll learn to multiply 2-digit by 1-digit numbers. What are 2-digit numbers? These are the numbers with 2 digits, like 12, 24, 83, so they have 2 digits, and 7 is a 1-digit number. So 12 times 7. I've shown here just 2 ways that I can represent 12 times 7 or 7 times 12, because they mean the same thing. So I've put lots of 12, 10 and the 2, 12, so there are 7 lots of 12 with orange cubes. With the brown cubes, I've shown 12 lots of 7, so there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lots of 7. They both give me the same amount or number. So I'll just show you one more way of representing 12 times 7. So this is how I'll show you. How is this 12 times 7? I've got 12 columns of 7 each, but I've got 7 rows of 12 each as well. So this is just another way to show it. And we'll go through the method of working these out as well. So one way to work this out, or one method to work this out, is called the grid method. How does that work? Now, I've got 12 on this side, so what I'm going to do is I'm going to split those into 10 and 2. So 10 and 2. And of course, there are 7 rows throughout. So I'll do the same thing over here. I'll create a small grid. Okay, so I've got 10 and 2, and I've got 7. So I've got 7 lots of 10, 7 rows of 10 each, which is easy to work out because we know that we got 10, 20, 30, 40, 50, 60, 70. So 7 times 10 is 70. It's nice and easy to work with. And then I've got 7 rows of 2 as well. So that is 14. So 7 times 12 gives me 70 and 14, which is 84. So notice what I did. I put these numbers at the top. So I split 12 into 10 and 2. And I've got 7 on the other side. Let's do one more example. Let's say we'll do 53 times 6. Okay, so 53, I'll split into 50 and 3. And the 6, I could put it here, but I could put it there as well. So I'll try it this way. It does not matter. So 3 times 6, or 3 lots of 6, is 18. 50 lots of 6, or 6 lots of 50. The easy way to work it out is by doing 6 times 5, which gives me 30, and add the 0 at the end, which is 300 now. So the answer is 318, which gives me 318. So this is the grid method. We'll now look at other methods. The lattice method works in a very similar way to the grid method that we've just seen. So I will again draw a simple grid. So I've got 2 numbers at the top and 1 number on the side, either side. So I'll put it here. So I've got 12. Now, difference between this and the grid is that I'll write 12 as I would do normally. So not separating it into tens and twos, tens and units, which is 10 and 2 in this case. So I've got 12 times 7. So I'll go 2 times 7 is 14. I'll separate those tens and the units here, and I'll do the same with the other one. 1 times 7 is 7, so these are 0 tens and 7 units. And I'll extend these diagonals. So in this part I've got just 4, so I'll write 4, and I've got here 1 and 7, which makes 8, and I've got 0 there, so I don't need to write that. So the answer is 84. Let's try it with another number. Let's say we've got, again, maybe 53 times 6 like we did before. So 53 times 6, okay, 2 digits. So I need to separate these in halves diagonally. 3 times 6 is 18, so 1 and 8. 5 times 6 is 30, so 30 there. Extend the diagonals. We have just 8 here. We've got 1 and 0, which makes 1, and I've got a 3. So 318 is the answer. We'll now look at the column method, which is the more traditional way of multiplying. 12 times 7. So what we do, we normally put the biggest number at the top. So 12 times 7. We line them up like this. So what we do first is we multiply 7 by the 2, by the unit. So it's like doing 7 times 2, looking at this lot first. Because what could happen, just like now, 7 times 2 or 2 times 7 gives me 14. And as you might recall from addition and subtraction, we, in addition specifically, we might need to carry over. So that's the case because 7 times 2 is 14. So I put the units down and I need to carry over that 10 to the next part. So now I'll do 7 lots of the 1, which is effectively 7 times 10 because the 2 holds the place. So that would be 7 times the 1, which is 7, and the 1 we had makes 8. So that value of that 8 is in fact 80 because we've got the 4 here instead of the 0. So that is 84. Now let's do the other example like we had, 53 times 6. So again, we start with the units. 6 times 3 gives me 18. So I put the 8 down and 1 carried over. So that 1, as we said before, represents the tens that we have, because in 18, 8 is the unit and that 1 represents the tens. So we're moving it to the tens column. Now we've got 6 times 5, which is 30, and the 1 makes 31. So 318 would be the answer. In this video, we'll look at multiplying 2-digit by 2-digit numbers using the grid method. What I have shown here using these cubes is multiplication. That is specifically 12 times 12. 12 times 12. How? There are 12 rows of 12 cubes each, or 12 columns of 12 cubes each. How can I break this down to demonstrate the grid method? So that 12 there is made of 10 and 2. So there is 10 and there is 2. Same thing on this side. Do 10 and we'll bring down 2. So what is this made of? There is this square, which is 10 by 10, and that's equal to 100. We've got these 2 columns in here. There is 2 lots of 10, but also 2 lots of 2, and there are 2 rows of 10 each. How do I show that? Using the grid method. So 12 is made with 10 and 2. And also the other 12 is made with 10 and 2. So 10 times 10 was 100, this area here. 2 times 10 was 20, and 2 times 2, this area here, is 4. 10 times 2, or 2 times 10, is again 20. So all together we've got 100 and 20 and 20 and 4, so 144. So that was the 100 and 20, 120, and another 20, 140, and the 4, 144. So this is how you use the grid method. I'll now do a few more examples. So let's say we've got 45 times 26. So 40 and 5 will be multiplied by 20 and 6. There we go. Now 5 lots of 20 makes 100. 5 lots of 6 makes 30. 40 lots of 6, or 6 lots of 40, we'll do by hiding the 0 first. So 4 times 6 is 24. Add that 0 back, because when you multiply by 10 you add a 0 at the end of the whole number. Now we've got 40 times 20, so we'll hide the zeros. We've got 4 times 2, which is 8. We'll add the zeros back, so that is 800. So all together this is 800 and 100 makes 900. 900 and 200 is 1140, and the 30, 1170. So just adding these numbers together, and we'll do another one. So let's say 58 times 60. So we do 50 and 8 will be multiplied by 60, and obviously there is no units, so you don't need that, or you could just do 0, but that makes no difference. So let's have a look. 8 lots of 60. So let's do 8 lots of 6 first, which is 48. Add the 0 back in, 480. 5 lots of 6 is 30. Add the 2 zeros, that makes 3000. So the answer is 3480. So this is how you use the grid method. We'll now multiply 2-digit numbers using the column method. So again, the 12 times 12 will be represented in a slightly different way. What I'm going to be doing is keeping this 12 as it is, so the rows will remain the same, but I'll split the columns. So this is 12, and this is split into 10 and 2. So this altogether is made by multiplying 12 by 10 and multiplying 12 by 2. So I'll write that as 12 times 2. So there we have 10 lots of 12, or 10 rows of 12, or 12 columns of 10 each to represent this area here, which is equal to 120. So if you look at that, what's happened when you multiply by 10, we've transferred this 0 over here, and then we've got 1 times 2 to make 2, 1 times 1 makes 1. So whatever the number was, we just added a 0 at the end. And if you look at this bit here, that is 2 rows of 12, or 12 columns of 2. So that is 2 lots of 12, that is 24. Both together, that make 120, and 24 makes 144. Now, if I put 12 times 12, what would I be doing? I'd look at the units first, so I'll ignore the tens. That's why I'm hiding them with my finger. So I go 2 lots of 2 makes 4, and 2 lots of 1 makes 2. So 2 lots of 12 in other way I've looked at, and that's 24, just like this one here. Now I'm going to move underneath to deal now with the tens. So I cross out the unit. Now I'm looking at 10 lots of 12, because 12 is made of 10 and 2. But since when multiplying by 10 we only add a 0 at the end, we'll put that 0 first, and we'll treat this as if it was a 1. So 1 times 2 makes 2, 1 times 1 makes 1. And that's exactly what we have done in this one here. Now I'm just going to add them together. So 4 and 0 makes 4, 2 and 2 makes 4, and that's 1. And together that makes 144. I'll now do a couple more examples using the column method. So if you've got 45 times 53. So again, we start with the units, hiding the tens. 3 lots of 5 is 15, so I'll put 5 down and 1 is carried over. 3 lots of 4 makes 12, and the 1 that we had makes 13. Just like we did with addition, we are carrying over lots of the tens. Now we're finished with the units, so we'll look at the tens, which the value of is 50. And to make my life easier, I'll just put 0 down, and we'll treat this as a 5. So 5 times 5 makes 25. So 5 down and 2 carried over. So 5 times 4 is 20, and the 2 makes 22. Adding these together, 5 and 0 is 5, 3 and 5 is 8, 1 and 2 is 3, and there we have 2, so 2,385. Let's have a look at another example. So let's say we have 86 times 24. So again, starting with the units, 4 times 6 is 24, so 4 down and 2 carried over. That's the tens. So 4 times 8 is 32, and the 2 is 34. Now we move into the 20s, so I'll put the 0 down. 2 times 6 is 12, 2 down and 1 carried over. 2 times 8 is 16, and the 1 makes 17. So we've got 4, 6, 10, 2, 2064. In this video we'll use the lattice method. So the lattice method is very similar to the grid method. Let's say we want to multiply 24 by 36. So with the grid method we do 20 and 4 times 30 and 6. So creating some grids 2 by 2 because there are 2 digits and 2 digits. So 4 lots of 30 is 120, 4 lots of 6 is 24, 6 lots of 20 is 120, 20 lots of 30 is 600. So all together we've got 600, 720, 840, 864. Now we'll do the same multiplication using the lattice method to notice a difference. I will do exactly the same grid. Instead of writing 20 and 4, I'll do 2, 4, so it's read as 24, and 3, 6 as in 36, but in the same order. And in addition, I'll split these into halves diagonally. So I'd put the tens and the units, tens and units, tens and units, tens and units. So 4 times 3 is 12, so I'll write it as this because the 1 represents the tens. 4 times 6 is 24. 6 times 2 is 12. 3 times 2 is 6. So what I'm going to do now, I will extend the diagonals. So we've got them extended. And I'll add all these numbers within the diagonals. So we've got 4 here, we've got 2 and 2 4 and 2 6, we've got 1 and 6 7 and 1 8, and that is 0. So 864, which matches what we had here. Now why does this work? If you look at the order, we always start with the units, so 6 times the 4 gives you the 24, so 4, but the 2 is carried over, just like in the other methods that we looked at. And then we've got here, we've got the tens multiplied by units, again tens multiplied by units, so we've got them added together, which means that it is, when you say 6 here, means 60 because there is a 4 to hold the units place in there. And similar idea with this when you've got the tens multiplied by the tens, so that makes hundreds as well because this is 800 and you've got units and tens to hold the place. We'll now look at a couple more examples using the same method, the lattice method. So I will do 45 times 83. So we've got 2 digits by 2, so 4 5 8 3. 3 times 5 is 15, 5 times 8 is 40, 4 times 8 is 32, 4 times 3 is 12. So we'll extend the diagonals we've got 5, we've got 0 and 1, which is 1, and 2 makes 3, 4 and 2 is 6, and the other one is 7, and then we have the 3 on that one. So 3,735 is the answer for this one. And we'll do just one more. Let's take another number. So maybe 57 times 46. So make the grid 57, 46. There we go. 4 times 7 is 28. 7 times 6 is 42. 5 times 4 is 20. 5 times 6 is 30. Now we'll extend the diagonals. We've got 2, 8 and 4 is 12, so 2 down and 1 is carried over. So we've got 2 and 3 is 5, and the other one is 6. And we've got 2 in the last one, so 2,622. In this video, we'll learn to round numbers to the nearest 10. Nearest 10, what does that mean? It means that you're counting up in tens and you're finding which of these tens is the number closest to. So we're counting up in tens just like before: 0, 10, 20, 30, 40, and so on. So I'll label these divisions in the number line. So 0, 10, 20, 30, 40, 50. As it happens, these are all pence, so we're talking about 0 pence, 10 pence, 20 pence, 30 pence, 40 pence, and 50 pence. Now, when you spend 29 pence on buying something, do you say you've spent 20 pence or roughly about 30 pence? I say about 30 pence, and the reason why is because if I try and place 29 in this number line, it is very close to the 30, and that's the reason why. If I had spent 21 pence, for instance, that would be very close to 20, so I would say I've spent 20, or if I spend 22, 23, or 24. 25 pence goes up to 30, 26, 27, 28, 29, again go up to 30. So let's have a look at the other examples as well. We've got 16 pence. So where does that fit? 16 pence stands between 10 and 20 because it's larger than 10, but it's smaller than 20. So there is 10 and that's 20. In the middle, right in the middle, will be 15. And we said that 15 would be rounded up. So that would go up to 20. But also all the numbers in between, such as 16, 17, 18, 19, they would go to 20. So 16, which is placed right here, is rounded to 20 pence in this case. Now let's have a look at 43. Where does that go? 43 is between 40 and 50. There would be 45, so 44, 43 would be here. And as you can see, 43 is much closer to 40 than it is to 50, so we'll round it to 40. Now 35. 35 is right in the middle between 30 and 40. And we said since that is right in the middle, it'd be rounded up. So 34, 33, 32, 31, and 30 would be rounded to 30, whereas 35, 36, 37, 38, 39 would be rounded to 40. Now, you're probably thinking, why is that the case? Let's have a look at which numbers will be rounded to 30. So as I said, 34 is one, so that's going to go to 30, 33, 32, 31, 30, 29, 28, 27, 26 and 25. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers that would be rounded to 30. And these are 25, 26, 27, 28, 29, 30, 31, 32, 33 and 34. Now, when it comes, since 25 was rounded to 30, now 35 will be rounded to 40. So these are rounded up. So we got 35, 36, 37, 38, 39, 40, 41, 42, 43 and 44 are rounded to 40. So that cutoff point is that 5. So we can say that if the number ends in 5, 6, 7, 8 and 9, we round up, meaning we go to the largest number. So look at that, 35 was rounded up, so we went to 40. Now, which are the digits that would be rounded down? So we've got 0, 1, 2, 3 and 4. So as we said, 30 would be rounded to 30, 31 would be rounded to 30, 32 rounded to 30, 33 rounded to 30 and 34 rounded to 30. So that means we're rounding down. Let's have a look now at rounding some larger numbers to the nearest 10. So we've got hundreds in here. So I will try and place these, but I'll split the divisions first into 0, 100, 200, 300, 400, 500. Now again, we're rounding these numbers to the nearest 10. So we'd still be counting as 0, 10, 20, 30, 40, 50, 60, 100, 110, 120, 250. So we counting in tens throughout. Let's place them where they belong first. So 132, where would that go? 132 is between 100 and 200. Halfway between them is 150. Now, is this bigger than 150 or smaller than 150? It is smaller. So I'll make a few more divisions here to see exactly where that's going to go. So 110, 120, 130, 140 and 150. This is specifically between 130 and 140. How do I know? Because I read this as 132, so it's larger than 130. So that's 110, 120, 130, and so that is here. Is it halfway through or is it closer to 130? That is, since it's 132, we can't place it halfway through, so it's closer to 130. So for that reason, I will round 132 to 130. Let's have a look at 288. Now 288 stands between 200 and 300. There is 250, 260, 270, 280, 290 and 300. 288 stands between 280 and 290. Is it halfway through? Is it 285 or more? It's actually more than that. So it's closer to 290. So I will write 290 underneath that. When it comes to 250, where does that stand? There is 200, 300, and we said this was 250, so it's right in the middle. But we're trying to decide which 10 it is nearest to. So we're looking at this digit, the 5 in there. Is it 250 or 260 that this is closer to? And as you can see, this is spot on 250. So to the nearest 10, that is exactly 250. So it doesn't change. Now 300 I have. Where does that stand? And that's again spot on 300 here, and that would be between 300 and 310 because we're looking at the tens. But since it's spot on 300, that's rounded again, that's already rounded, so it's 300 to the nearest 10. Now another way to do these would be to actually look at the last digit, as we said, at the units. And we went through the digits here in the previous example. So I'll use this method as it's then quicker to work with once you know what we're talking about. So we've got 16 pence to the nearest 10. So let's identify the tens digit. So that is 16, which means 10 and 6 pence. So the tens are here. The 6 is the unit and the 1 represent the tens. So I want to round this, meaning I'd keep it as 1, which would be just 10, or I'd make it into 2, this digit, to make it 20. So I either say this is 10 or 20 to the nearest 10. And to decide, I need to look at the units, at the digit on the right. So that is a 6. And what did we say? If that digit is a 6, then we round up, meaning that we'll go to 20. And that's exactly what we did when we went through the number line. Now let's look at 29. Again, we need to round to the nearest 10, so that's the 10th digit. Looking at the digit on the right, the units, that is a 9, which means that we're going to be rounding up. So this becomes 30, and that's what we decided before as well. 35, again, we need to round that either down or up, so it's either 30 or 40. So we've got the 5 to look at, so that 5 is in the digits that mean we round up, so that's going to be 40. And 43, again, rounding this into 40 or 50, look at 3, that is one of the digits that we round down, so we'll go to 40. Now let's do these ones as well. So we've got to look at the tens. Where is the tens? And that's the tens digit. And then looking again to the right, so units determine, that's a 2, which means we round down, so that's why we keep it 130. 30. And looking at 288, the digit that represents tens is this one, but we need to look at the units on the right to determine, and that is an 8, which means we round up, so this becomes 290. 250, the digit that we need to round is this one. Do we keep it 250 or go to 260? And the 0 next to it tells us where we need to round down, so we need to stay with 250. 300, where is the digit that represents the tens? This is the 1. So again, that's a 0. Do we keep it as 0 or do we go up to 1? We look at the units, and that's a 0, which suggests that we stay down, so we keep it as 300. We'll now look at some worded questions examples. So we've got Alia went shopping and bought a pair of trousers for £18, a bag for £22, and a top for £13. Estimate the cost of Alia's shopping. So we asked to estimate, not to work out the exact answer. And when we estimate, we use rounding. With these numbers, it seems right to round them to the nearest 10. So I'd round this to 20 and this to 20 as well, because it's 22 and 2 is lower than 5. And we've got 13 as well, which will be rounded to 10. So we've got 20 and 20 and 10. Altogether, this makes 50. So £50 would be my answer. Let's double check. I've got 18 rounded to 20, 22 rounded to 20, 13 rounded to 10, and that is an estimate of the cost. Now the other question asks, Hannah spent 60 pence on a notebook, 8 pence on a curry bag, and 29 pence on a ruler. How much did Hannah spend in total? So we've got to take account of these prices, and total means we adding them together. Is this asking for us to estimate? No, it's not. It's all it's asking us to do is to actually work out the total. So I will go 60 and 8 gives me 68. Then I'll add 29 to it, so I'll go 68 plus 29. 60 and 20 makes 80. 8 and 9 makes 17. So 80 and 10 is 90, and the 7 is 97. So 97, what's the unit? It's pence throughout, so it's got to be pence. 97 pence is the cost. That's how much Hannah spent in total. Now the next part of the question says, check your answer by rounding to the nearest 10. So I've got to round these amounts to the nearest 10 to work out the total, to check that I've got this total correct. And if I get something that is close to it, that means I've got it right. So 60 pence to the nearest 10, that is 60. 8 pence to the nearest 10, that is 10. And 29 pence to the nearest 10, that is 30. So 60 and 10 is 70, and 30 is 100. So that gives me 100 pence, or £1. And is that close to the 97 pence that we had before? It is. So that means I've checked my answer and it was right. If the answers didn't match, they were far away from each other, then I'd go back and check this again, that I got it right. Now we'll look at rounding numbers to the nearest 100. So rounding to the nearest 100 means we're counting up in hundreds, like 0, 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1000. So what I'm going to be doing here is placing these numbers, amounts, whatever you want to call them, because you've got different units in there. You've got pounds, you've got pence, meters, so centimeters. The unit does not matter. You still round in exactly the same way. So I'm going to try and place them in the number line. So I'll first start with this. So I've got 199 pence. Where do I place it in the number line? 199 suggests that this is between 100 and 200. So looking at placing this here, 199, as you can see, is very close to 200. So just one more pence and you'd get 200 of them. So I'll place it here, and as you can see in the position in the number line, this is very close to 200. So we'll round it to 200. Now we'll look at another one. So we'll take 70. Where is 70? 70 is in between 0 and 100. Halfway through 0 and 100 is 50. So obviously this is going to be about at this point. So that is, as you can see, closer to 100 than it is to 0. So we'll say this is rounded to 100. Then we have 600. Where does that go? 600 is spot on, although the number itself is between 600 and 700. 600 is spot on top of 600 mark, the 600 mark, so that is rounded to 600. Doesn't make sense to go to 700 because that's very close to 600 on it. And then we'll take 148. So 148 is between 100 and 200. 150 is halfway through, which is the point when you round up, but this is less than that, so that is just under 150, so we'll round this to 100. And we'll now look at 28. So if you look at 28, 28 is closer to 0. So it's not 50, which is the point where you round up to 100. So that's rounded to 0, to the nearest 100. 50 then is right in the middle. So that means we round up, we go to 100. And 960, where does that go? So that's between 900 and 1000. 950 is right in the middle, and this is more than that, so for that reason we'll round it to 1000. So we'll now look at the other method of actual rounding. We've placed them numbers in the number line, but we'll look at the other method. So let's have a look at these numbers. So we've got 148. We run into the nearest 100. So where is the hundreds column? That's here. That's the digit that represents the hundreds. To decide, we look at the digit on the right, which happens to be the tens. Why do we look at the digit on the right? Because we said this is, we're kind of trying to place it in the number line, and if it's less than 150, then we round down, meaning we go to 100, and if it's 150 and over, then we round it up to go to 200. And we have the digits as well here, so, and on the other side, so we've got 148. Looking at the 4 is one that suggests we go down, and for that reason we go to 100. We don't go up to 200. Now let's have a look at this. 199, again rounded to the nearest hundred, means we locate the hundredth digit. Looking on next to it on the right, we've got a 9, and that 9 is in the digits that go up, so 5, 6, 7, 8 or 9, and that's a 9, meaning that we're going to round up to go to 200. Let's have a look at this. So we've got 70. Obviously we haven't got a digit that represents the hundreds. That would be over here. So we look at the ones next to it on the right, and that happens to be 7. So 7 is one of the digits that we round, means we round up, so we go up to 100, because this is currently a 0, so we either keep it as a 0 or we go up to 1, and 7 told us that we need to go up to round up, so we go to 100, and there we have 600 here. So that's what we need to round to. Is it going to stay as 6, or is it going to go up to 7 to make 700? And obviously looking at the digit on the right, that is a 0, which means we round down, so we stay with 600. And looking at 960, that's the hundredth digit. Look at the 6, that's one that goes up, so this can't stay as a 9, it's going to go as up to 10, so we make 1000. And 50, again, the hundredth digit would be here, but at the moment there is no digit, so it means it's a 0. And looking on the right, we've got a 5, which means we round up, so we go to 100. And finally we've got 28, again no hundred digits, so it's a 0. Looking at the 2 to determine whether we stay with 0 or go up to 100. That means that we stay down, we round down, so we're going to go to 0. And this explains how to round numbers to the nearest 10 and 100. So we'll now look at some worded questions. Alia went shopping and bought a pair of trousers for £184, a bag for £260 and a top for £35. Estimate the cost of Alia's shopping. So since we're talking about hundreds of pounds here, it makes sense to round to the nearest 100, because we haven't been asked to round to the nearest 10, for example. So what I'm going to be doing is I will round these. 184 to the nearest 100 is 200, because this is closer to 200 than it is to 100. So I'll write 200. 260 to the nearest 100 is 300. And 35 to the nearest 100 is 0, because it's below 50. So I don't even need to add that, since 0 doesn't add anything. So 200 and 300 makes £500. Let's double check. That was rounded to 200, this is to 300, and that was 0. So that should give us a rough figure of how much Alia spent shopping. Hannah is building a dollhouse using wood planks. She needs 455 centimeters for the windows and 105 centimeters for the doors. How much does she need in total? So we haven't been asked to estimate, so we're going to have to work out the total. Now the easiest way I can work this out is to have 455 and the 105 added together using the column method. 5 and 5 makes 10, so the 0 down and 1 carried over, 5 and 1 makes 6. 5 and 1 makes 5. So 560 centimeters, because we use centimeters for both. So the result is going to be in centimeters. Now we've got to check the answer by rounding to the nearest hundred. 455 to the nearest hundred. That is in between 400 and 500, and it's closer to 500, so I'm going to say 500. 105 to the nearest hundred. It is between 100 and 200, but it's much closer to 100 because it's 105, just 5 more. So all together, that gives me 600. Is that close to this? It is close to this. And actually, if you round 560 to the nearest hundred, it'd give you 600. So we've got that calculation right. But if this was much more different from that, then I would go back and check this calculation and redo it. In this video, we'll learn to recognize and continue sequences of numbers up to 100. I've put in a row some cubes. If you look at them, the first one, there is just one cube, and then we have 3 cubes, and then 5, and then 7. So the next one you'd think is a 9. Why? Because to get from 1 to 3, we've added 2. To get from 3 to 5, we've added 2 again. To get from 5 to 7, we've added 2. So we must add 2 as well to 7 to get 9, to get the next number. And of course, if you want the next one, you'd add 2 again to make this 11. So to recognize sequences, it means to look at the numbers and notice what is the difference. What are we adding on or taking away each time? So a sequence is these numbers being put next to each other in a row, and they have the same gap in between them. So I will add another sequence here. Let's do 2, 5, 8, 11. So we'll try and add the next 2 terms. To get from 2 to 5, what do? We add 3. Let's see if that's the case from 5 to 8, and that is the case. 8 to 11, we add 3. So to get to the next one, we must add 3. So that means we're going to get the 14 here, add 3 again to get 17, and so on. So that's another example of a sequence. But it doesn't have to be numbers like 2 and 3 added. It could be larger numbers, and I will include one here with some larger numbers. So to get from 21 to 28, we add in 7. To get from 28 to 35, we add in 7. So we must add 7 to the next one. So if I add 7 to this, this becomes 42. So I found the next one. But you may be given these, and you probably have to work out the first term. What is that first term? So if the difference between 28 and 35 is 7, between 35 and 42 is 7. So the same difference will be between this first term and 28. So how do I find what is that missing number? Now, when I went this way, I added 7 each time. So I'm supposed to be doing the opposite, which is taken away. So that is one way of looking at it. So 28, take away 7, leaves me with 21. Does that still work? Look, 21 add 7 gives me 28. So I've found the right number of the sequence. So this gives me and you some examples to look at in terms of sequences. And examples from everyday life include all the odd numbers, like this one here, 1, 3, 5, 7, 9, 11. They're all odd numbers, so it's a sequence of odd numbers as well. Or you could have all the even numbers, which is 2, 4, 6, 8, and so on. But it doesn't have to be adding on. Sometimes you might be taking away. So if you look at this example, 10, 8, 6, 4. So what's going on there? From 10 to 8, we're not adding, but we're taking away. How many are we taking away? It's 2. So take away 2. From 8 to 6, we're taking away 2 again. And same thing from 6 to 4. So what do you think is going to happen next? What number would we have? Again, by taking away 2, we get to 2. The next one, take away 2, leaves me with 0. So you've got to look at what's happening from one term to the next one and apply it again. In this video, we'll learn to read, write and understand thirds, quarters, fifths and tenths. Now, in a previous video at entry 2, I looked at quarters and tenths. So if you need to revisit these, please have a look at the entry 2 video on fractions. So now I will focus on thirds and fifths. Again, I'm referring to a pizza, which has been cut into 3 equal parts, because that is what a third is. One slice is 1 out of the 3. So 3 means that I've cut it into 3 equal parts, and I'm taking away 1. So this is what 1/3 means. If you want to look at it, I'll try and cut off 1/3 of the pizza. And here it is. This is 1/3 of the pizza. It means it's been shared out in between 3 people, or you've cut it into 3 slices and you're gonna eat just 1 for the time being. Maybe later on you have the rest. So that's how we read it, as 1/3, 1/3, or a third, which also means 1 out of 3. So 1 out of 3. I will try and represent a third of these rectangles as well. So this could be 1/3 of this. So equal parts, 1 part. This is 1/3, this is 1/3 as well. I could split these horizontally as well. So this is 1/3, this is 1/3, and that is 1/3. How do we work out 1/3 of an amount? Let's suppose that the whole pizza costs £12. So all of this pizza costs £12. I want to find out what is 1/3 of the cost. So I've got 1/3 of the pizza. How much would this be worth? How much would this cost? So look at that. How many people would share this and have equal pieces? And that would be 3 people. 1, 2, 3. Or just 3 slices. So that means we're sharing the cost equally as well. So is this being halved? No, it's not. It's been cut into 3. So it's sharing the cost in between 3. So I will divide 12 by 3. How many 3's fit into 12? And that is 4. So that is £4. 1/3 of 12 is £4. What would be 1/3 of, let's say, 24? So that is 24 again, split into 3. That gives me 8. So that would be £8. Okay, what would be 1/3 of 72? 72 meters, 72 liters, whatever it might be. So again, 1/3, that suggests we're sharing it into 3 parts. We're dividing it by 3. So how many 3's fit into 7? That is 2 of them, and there is 1 remaining. So how many 3's into 12? And that would be 4. So the answer would be 24. So to find 1/3 of an amount, you'd again divide it by 3, or share it into 3, just like with the shape, just like with the pizza. We're now looking at 1/5. So that is 1 out of 5, or 1 divided by 5. So if you look at the pizza, I've cut it into 5 equal parts. Let's have a look at just one slice. So what I've taken away is 1/5 of the pizza. How does 1/5 of a rectangle look like? So we'll have a look at 1/5 of this. So we could split it into 5 equal parts like this, or horizontally. So this gives me 1/5. This gives me 1/5 as well. So what is 1/5 of £25? So let's suppose that the whole pizza costs £25. What is the cost of just one slice? So sharing out equally. So that would be divided into 5, just like the pizza was cut into 5. So 25 divided by 5, that gives me 5. So 1/5 of £25 is £5. What would be 1/5 of 55? So 55 again, shared equally by 5. 5 into 5, it's 1. 5 into 5, it's 1. So again, it'd be £11. Let's find now what is 1/5 of 130. So 130 meters, liters, kilometers, whatever it might be. Finding 1/5 of it, 130 divided by 5. So 5 into 13 fits twice, and there is 3 remaining. So 5 into 30 fits 6 times, so 26 is 1/5 of 130. So to find a fifth, again, you've got to share that number into 5, divided by 5. In this video, we'll look at equivalent fractions. What does equivalent mean? It means equal. So we're looking at fractions that are equal to each other. So I'll show a third of a fraction. So I've split this into thirds. So this is 1/3. So it's a pizza that 3 people share. One person would get 1 slice, and that's how big the slice would be. Now, another group of people buy another pizza, which is exactly the same size, but it's 6 of them, 6 people. So what they will do is share this equally as well. So how much will a person get? They will get 1/6. But if you compare and we try to find what a third of the pizza is equal to in terms of sixths. So how many sixths would make a third? If you try and compare these, this whole thing would make 1/3. So I'll try and bolden these to show what a third looks like. And so 2/6 make a third. 2/6 make a third. So what has happened to the number of slices? The number of slices has doubled. It was 3, it is now 6, because these slices are much smaller, although they've doubled. So in terms of the overall amount, the size of the pizza, that hasn't changed. And what actually happens to the slices that we're talking about? It was 1 slice, that's equal to 2 now. So we double those as well. So we've got 2/6. Now the same thing would happen if we had a pizza and it was shared in between 9 people. So that would be a third, but now that has to be shared between 3 people, that third, because there are 9 in total. So that makes this area here makes it is 3 slices out of 9 in total. So what has happened to the overall number of slices? It's gone from 3 to 9. So it's been multiplied by 3. What has happened to the number of slices we're talking about? To the equal ones, to the third. That is equal now to 3 smaller slices. So again, that 1 has been multiplied by 3. So what do you notice? When we multiply the top and the bottom number by the same number, then we get an equal fraction. So 1 times 2 gives you 2, 3 times 2 gives you 6, so that is an equal fraction. The slice, the amount has not changed. Then again, 1 times 3 gives you 3, 3 times 3 gives you 9, so that represents the same amount. This just tells us that we split the pizza into smaller slices. There are more slices, but smaller. Now let's do quarters as well. So here is a quarter, 1 out of 4, and again the pizza, if it's been split or shared by 8 people, that area now is represented by 2 slices out of 8. So again, what's happened is that 1 was multiplied by 2, doubled, and 4 was multiplied by 2 as well. So the fraction is still the same. The highlighted area is still the same. And the same thing would happen if this was split into more pieces. Okay, let's suppose we share these into 16. So a quarter is this area here. So that is 1, 2, 3, 4. That is 4 slices out of 16 in total. So what has happened? To get from 1 to 4, we've multiplied by 4. As you can see, within the one bigger slice fit now 4 smaller slices, and the 4 that were in total now have become 16 because they're 4 and 4 and 4 and 4. So we multiplied the bottom number by 4 as well. Now we'll look at fifths. So I'll show a fifth. Here is a fifth. 1 out of 5. And we'll share this pizza into 10. Split it into 10 equal parts. So that 1/5 now is represented by 2 slices. So it's 2 out of 10 in total. So we doubled the number of slices. So we also doubled the number of slices that fit into the bigger slice. And let's try one more. Let's so that is a fifth. So that area is represented by 3 slices out of 3, 6, 9, 12, 15. So looking at the numbers now, that 1 has been multiplied by 3 to give us 3, and the 5 has been multiplied by 3 to give us 15. And finally, we'll look at a 10th. equal parts. Here is a tenth, and now we'll share the same amount into 20. So I'll do it into 10 first, and we'll halve those again. So where there was just 1, it'd be 2 now. So 2, and the number of slices overall is 20, so it's doubled as well. So we'll try and show that a bit more clearly. So 1 slice has been replaced with 2, and what happened, we doubled the top number, we doubled the bottom number as well. And that showed just one more equivalent fraction. It's going to be more difficult to show because there will be more slices. So I'll show 3 for each one. So one of the bigger slices is represented by 3 smaller slices now. So I've got 3 in the highlighted area, 3 out of 30. So again, to get from 1 to 3, we multiply it by 3. To get from 10 to 30, we multiply by 3 as well. So we could also multiply by 6, 7, whatever number. If you multiply the top and the bottom as well by the same number, it will give you an equivalent fraction. In this video, we'll learn to read, write and use decimals. We've got money as an example here, but we also use decimals when it comes to length, weight and capacity. So looking at liters, meters and kilograms. I've got a number of 10p coins in a row. There are 10 of them, which means that from this point to this point, all this is worth is £1. So we started with 0 and we ending with 1, a whole pound. And this is how decimals usually work out of 1. They go over 1 as well, but we compare them to that 1 whole. So we start with 0, and then 1 10p coin is 0.1 parts of the whole pound. That is also 0.2, 2 of them, 0.3, 3 of them, 0.4, 4 of them, 0.5, 5 of them, or half of it, half of the pound. 0.6, 7 will make 0.7, 8 will make 0.8, 9 will make 0.9, and 10 will make a whole pound. So that is how we represent decimals using money out of a whole pound. Now, I've written 0.1, 0.2, 0.3, 0.4, but we also know that money is written with 2 decimal places. So 10p coin, a 10p coin is written as 0.10, like that in a shop. So I'll make it a bit bigger, 0.10, which means 10 pence. So there are no pound coins yet. There is one 10p coin and there is no single pennies. So this represents 10 pence. And this would represent 20 pence. And this would represent 30 pence. 40, 50, 60, 70, 80, and 90. So 0.1 is exactly the same as 0.10, because there are no pennies after that, no single penny coins like this after that. It's just a 10p coin in its own, and two of them will make 0.20, and that's 0.30, 0.40, 0.50, 0.60, 0.70, 0.80, 0.90, 1 or 1 pound. Let's see how we can read and write these other decimals. So again, these are 5 penny coins, 5 pence coins. All together, they make 1 pound. So this is 1 pound. So we're starting with 0 and we're ending with 1. Up to this point, as we looked at the example before, it was 0.10. This here was 0.20, because 5 and 5 makes 10 pence, which is what one of these is worth, so they have equal value. Now we've got 20 pence, so that comes to that. Now we've got 30 pence, so 0.30, 0.40, 0.50, 0.50 or 0.5, 0.60, 0.70, 0.80, 0.90, and a pound finally. So what would we put in between these? Since we don't have 10p yet, I'm going to write this as 0.05. So we have 5 pennies, but we don't have any 10p coins, and we don't have any pounds. And this one here will be a 0.15. So I've got 15 pennies. This is going to be 0.25 between the 20 and the 30 pence. 0.35, 0.45, 0.55, 0.65, 0.75, 0.85, and 0.95. So if you look at these after the decimal point, which separates pounds from the pennies, we've got 0.5, which is 5 pence. We've got like a 10 in there, which represents 10p, 15, 20, 25, 30, 35, 40, 45, up to 100, which makes 1 pound. Let's now look at the pennies. As you know, we need 100 penny coins to make a pound, so there are 100 of them here. Again, all of these make a pound. We start with 0 and we end with 1. So up to this point again, we've got 10 pence, which is equal to 0.1 or 0.10. Now 0.20, 0.30, 0.40, 0.50, 0.60, 0.70, 0.80, 0.90, and 1 pound. But what is just one of them worth? if you go back to this example, we had 5 pence was 0.05. So we can see that 0.5 representing 5 pence. Now one of these is going to be 0.01. So there is just a penny. 2 of them will be 0.02. 3 will be 0.03, and so on. We're up to a point where we have 0.10. So you can see that 1, 2, 3, and that 10 after the point, which we read as 0.10. And then we've got 0.11, 0.12, 0.13, up to 0.20, 0.30, 0.40, 0.50, 0.50, 0.60, 0.70, 0.80, 0.90. So here would be 0.91, 0.92, 0.93 to 0.99, and then there comes 1. So we've got to look at them and at the value that they represent. So it's out of 100, so we've got 0.99 just before the 1. And we're not going to write 0.100 because that is not the same as £1. £1 comes here where the value of a pound is. So to have a look at how and what decimals represent, if I have this amount, that would mean that I have £1 and 15 pence, because the decimal point represents or separates pounds from the pence, and this amount would be £2 and 5 pence, whereas this would be £2 and 50 pence, or this would be £0 and 0 pence. So if I am to order these, put them in order from the smallest to the biggest, I would look at the pounds first, or the whole numbers first, even if they don't have a pound sign in front. Let me just take these away. I want to compare these, I want to put them in order. So I've got, this is a whole pound and 15 pence. So I'll look at the whole pounds first. Which one has less of it? Which one has less of the pounds? So we've got 0 in there, so that must come first. So 0.05, so £0 and 5 pence. And then out of the rest of them, I'll look, and that's the lowest one, that is just 1. So that would be £1 and 15 pence, or 1 whole meter, and 0.15 of it as well. That out of them two, we have £2 and 5 pence comes first, 5, and finally £2 and 50 pence. So you look first at the whole number, which is before the decimal, and then you look at what is after. As you can see, when we compare these two together, the one with the 5 that is next to the decimal point, which represents the 10p coins, has a greater value than the 5 that is a place after, so which represents 5p coins. So this is 50 and that is 5 pence. So we've kind of compared some decimals and we've ordered them. As we mentioned before, we use decimals to also represent liters and meters, kilograms. So if this wasn't money, if I didn't have 0 to 1 to represent a pound, I could in fact represent a liter. So that would be 0, that would be a liter, and that still applies. So that would have 0.1 here, 0.10 if you want, or 0.20, 0.3 or 0.30, 0.4, 0.5, 0.6, 0.7, 0.8, which means the same as 0.80, 0.90, and we've got 1 liter at the end. So it starts with 0, it ends with 1. Same thing could be with a meter, for instance. Let's suppose this is a meter, and again we start with 0, we end with 1, and that would be 0.1 or 0.10, and that would be 0.05 parts of a meter, 0.10 parts of a meter, 0.15, 0.20, 0.25, 0.30, and so on, exactly like the ones above, because this is split into 20 equal parts. So again, we've got to think 10 parts, so 1 out of the 10 parts makes 0.1 or 0.10. So that there are 20, so 2 of them might make 0.10 or must make 0.10. That's 0.20. So that's 2 parts. Whereas looking at this one now, let's suppose it's kilograms. So we have liters, meters, and kilograms. That again starts with 0 and ends with 1 kilogram at the end. So 0.5 or 0.50, half of it would be here. And similar to the previous example, that would be 0.1, this would be 0.01, 0.02, and so on, just like in the example above. So decimals are represented in the same way, whether it's money that we're looking at, liters, meters, kilograms, or grams, or whatever unit, whole unit, but what we're referring to is always a whole thing. So if we're comparing, this is 1 and or 0.15, so 1 pound and 15 pence, and that is 2 pounds and 5 pence, and that is 2 pounds and 50 pence, and this is no pounds, so just 5 pence. In this video, we'll learn to recognize and continue sequences of decimals with 1 decimal place. A decimal with 1 decimal place is one that has 1 digit after the decimal point. So if you look at this 1.2, it has only 1 digit after the decimal point. So that's what we call a decimal point. This is the decimal point, and this is a decimal place. So 1.5 is another decimal with 1 decimal place. Whereas this is a decimal with 2 decimal places. So the ones that we're going to focus on are these ones with 1 decimal place. You can see that I've got some rows of coins here. So I'll write what they represent, what they mean, how much they're worth. So this first one is 0.1 part of a pound. It's 10 pence, and I write it as 0.1 or 0.10. Then this represents, because it's 2 of them, 0.2. And this is 0.3. So what's happening every time? As you can see, I'm adding an extra coin every time. So you can expect that here will be an extra coin. I've got 3 already, we'll add another one, so that will make 0.4. And then 0.5, 0.6, and so on. It would be this exactly the same even if I wrote this. This probably helps you because you know that this is how we write money in with a pound sign in front. So that means 10 pence, this means 20 pence, 30 pence, 40 pence. What am I adding every time? I'm adding 10 pence every time. Now we'll look at the next example. We've got 50 pence, and that is half of a pound, so I'll write it as 0.5. And 2 50 pence coins make £1, so 1 comes next. 3 of them make 1.5, so I'd write it like this. If I add another 50 pence coin, that would make £2. So I'm referring to pounds because it's easy to, and we use money every day. However, when I'm writing these, I'm not using money because you could have a sequence without the pound symbol. So I want us to get used to doing both of them. So we've actually done this one. Now let's look at the next one. So this is 2 pence. So the way that we write 2 pence is this. So we leave a gap of 0 for the 10p coins because we haven't got any. And we write it as 0.02. Now I have 2 of them, so this is going to be 0.04, 0.06, 0.08. And what would happen next? What would be the next one? That would be 0.10, because that would mean now I have 10p. So we're challenging ourselves and we're moving to 2 decimal places at the bottom. But I will show some other examples where we use 1 decimal place as well. So I'll write a short sequence here. Now if you have 0.6, 0.9, 1.2, what's happening every time? To get from 0.6 to 0.9, we add in 0.3. To get from, or 30 pence if you like, to get from 0.9 to 1.2, again we add in 0.3 again. So we must add 0.3 to 1.2 to get the next term. So that makes it 1.5, 1.8, and so on. Maybe you find it easier to add a 0 here because after the decimal points and the digit, that doesn't make any difference. So if you prefer it, then we have 60 pence, then 90 pence, then £1.20, £1.50. Another one, so let's say we have 0.8, 1.2, 1.6. Find this missing value there. So in order to find that, I would go and look at the ones that I have. What's happening? To get from 0.8 to 1.2 or 80 pence to £1.20, what am I adding? I'm adding 40 pence or just 0.4. And same thing here, I'm adding 0.4. So I must be adding 0.4 to this first number to get the second one. So, or I can take away 0.4 from the 0.8 to give me 0.5. 0.4. Let's check. 0.4 and 0.4 gives me 0.8. And one more example. If we have, let's say, 5.8 and then 5.4. So what's happening here? What do you notice? From 5.8 to get to 5.4, we're actually taking away, not adding. So we're going from £5.80 to £5.40. That means we're taking away 40 pence or 0.4. So what we'll be doing to the next one is taking away 0.4 again. So 5.4 take away 0.4 or 40 pence leaves me with just 5. So I hope this has given you some ideas. It's clarified what it means to recognize and to continue sequences of decimals with one decimal place, but there was one example with 2 decimal places as well. In this video, we'll learn to calculate with money using correct notation. Now, we use money in everyday life, so it's really important that we write it using the correct notation, so we don't mistake the pence or the pounds. We know how to add and how to subtract them. So I've got this amount of money which I've lined up based on their value, because always in terms of money, when we write them down, the coins with the higher value come first, and that's how we calculate money. So as you can see, I've got a pound and 50 pence and 5 pence. So the decimal point represents or separates the pounds from the pence always. So I would write this as £1 and 55 pence. Notice how the pound is on top of the 1 because there is £1, and that's where its place is. And then point, we've got the 10, 20 or 50 pence coins because we read this as £1 and 55. So there come the tens, and in this case it's 5 tens or 50, and 5, just 5 pence. It would be the same as 5 1p coins. Now let's look at this one. So do I have any pound coins? Do these make a pound? That is just 10 and 2, so it's 12, just 12 pence. No pound, so I'll put a 0 in front and put the decimal point next. So these are in the correct order as well. So we've got the tens, 10p coins first, so that makes there is just one 10p which is worth 10 pence, and we've got 2 pence after that, so it's 12 after the decimal point. That 12 represents the 12 pence. And what I have here is £10 and 20 pence. I haven't got any pennies, so it's going to be 20 pence. So what I'm going to do with these amounts, first of all, I'll add these two together and then I'll subtract it from this. So here is the cost of, let's say, a can of beans, and here is the cost of a carrier bag, and this is the money that I've got in my pocket. So let's add these two together. Notice how I line them up. So I've got £1 and 55 pence. Now I've got 12 pence here, but I've got to make sure I've got a 0 under the pounds column, and I've got the 12 pence where they belong. So that's the 10p column after the decimal point, 10p column as well. So I've got them lined up, and I can see that the decimal points are under the decimal points always. So I'm going to add them. So I go starting with the units, just like with whole numbers. So 5 and 2 make 7, 5 and 1 makes 6, decimal point underneath, 1 and 0 makes 1. So these two together cost £1.67. Now here is my budget. This is what I have in my pocket. How much would I have left after I've paid for this? So I'll write this £10.20. Take away £1.67. Now always reference points, put the decimal points under the decimal points, and that would help you. This here represents the units. So I've got a unit, I've got £1. I haven't got 10, so I can't put it there, or 20 or 30 or whatever. So I'm gonna have to put it here under the units. And also this is just before the decimal point. So decimal point here, that should go just before the decimal point where I line them up as well. After the decimal point, I've got a 6 and then a 7. And that matches because that is 20 pence and this is 60 pence. So the tens line up, tenths or 10p coins, and the 1p coins over here. I haven't got any when it comes to 20 pence. I haven't got 21, 22 or 23 or so on, but I've got 67. So there are 7 pence in this amount. I'm going to take them away. So I need to take away 7 from the 0, but I can't really do that. So I'm going to have to borrow 1 from the 2. So the 2 becomes a 1 and the 0 becomes 10. So 10 take away 7 leaves me with 3. Now 1 take away 6. Again, I can't really do that, so I'm going to have to borrow 1 from the 10. So that becomes a 9 and this becomes 11. 11 take away 6 gives me 5. 9 take away 1 leaves me with 8. So what I've just done is that I borrowed £1 from this, so that gave me 10 10p coins. That's why from a 1 that became 11, so 11 10p coins in total. And this shows how to represent money or write money using correct notation, but also calculate with money, so adding and subtracting money. In this video we'll learn to round money to the nearest pound or 10 pence. I've got 4 different amounts, price stars with amounts on, and what I'll do is I'll round them to the nearest pound and 10 pence as well. So round to the nearest pound, what does that mean? As the name suggests, you're looking at which pound or amount in pounds that is closest to. So when you say to the nearest pound, we're counting in pounds only. So 0, 1 pound, 2 pounds, 3 pounds, 4 pounds, and so on. So if you look at 0.72, that stands between 0 and a pound. So we'll show that here, 0 and 1 pound. 50 pence would be in the middle. This is 72, so perhaps here. And as you can see, that is closer to a pound. So we'll round that to the nearest pound. That would be 1 pound. To the nearest 10p we'll look at in a minute. So this one, which amount in pounds is that closer to? So that is between 16 and 17, but it's actually spot on. And we said in previous videos that when it's halfway through, when it's between 16 and 17 and right in the middle, so 1650, we round up. Anything less than that, if it's 1649, then we're going to round down. So for that reason here, we'll round this to 17 pounds. So to the nearest pound, this is 17. What is 89 pence to the nearest pound? Now, again, this stands between 0 and a pound. So 89 is probably here, and it's very close to a pound, so we'll round it up. So the answer would be 1 pound. And how about a pound? That is spot on here on 1 pound, so we'll round it to a pound. We can't say 2 because that would be much further away. So that is again 1 pound. Now we'll look at rounding these amounts to the nearest 10 pence. So the focus now, rather than on the pounds, is on the pence. We've got the pounds, and we look at the 10p coins, the value of the 10p here. So we've got 0.72 or £0.72. So this is 72 pence, and that is between 70 and 80 pence. But it's only 72, so it's very close to 70 pence. It's much further away from 80 pence. So for that reason, we'll say 70 pence. Or actually, the better way to write it, since it's given in pound notation, would be this. This was 1 pound, and this was 17 pounds. So now this is 16 pounds and 50 pence. So focusing on the 10p column, we've got a 5 there. So this stands between £16.50 and £16.60. But it's actually spot on 50, so it's £16.60 is much further away from this. For that reason, we'll actually round it to £16.50, so it won't change. If it was £16.58, that would be much closer to £16.60. So that's why we round it to £16.50. Looking at this, 89 pence. Now 89 pence stands between 80 and 90 pence, but it's very close to 90, so we'll round it to 90 pence. Where is 1 pound? So a pound is between 1 pound and 2 pounds, or between 0 and 1 pound. And are there any 10p coins? No, there are not. No, there are not. So we've got this being at this point. So we can't say this is rounded to 1 pound 10 pence, for instance, because it's much closer to the 1 pound itself. So 0 10p coins. So again, to the nearest 10p, this would be just 1 pound. And if you look at the other method as well, where we identify the digit for the 10p, we would look at where is the 10p coin value, where is the digit, that's a 7. So we'll look at the digit on the right, that is a 2, which means we stay down, we round down. So we keep this as 70. So £0.70. And same thing here, identify the 10p coin digit, and that is here, 50. The way we read it, £16.50. So there are 5 10p coins or a 50. And to decide whether we keep this as £16.50 or go to £16.60, we look at the digit on the right, and that's a 0, which means we stay down. So we go to £16.50. And 89 pence, where is the 10p coin digit? And that is here. So we've got to either keep this as 80 pence or go to 90 pence. And looking at the 9, that tells us that we've got to round up, because it's 5, 6, 7, 8 and 9 that mean we round up, so we go to 90 pence. And we've got the pound, so the 10p value coin column would be here. We've got 0, so it's either we stay 0 or go up to 1. Looking at the next digit, that is 0 as well, so that means we stay down, and we're left with £1 as well. And rounding to the nearest pound, so we locate the pound column, there it is, the unit. So we've got a 0, looking at the digit on the right, that's a 7, which means we round up, so we go to £1. And looking at £16.50, that's the unit or the pound. And again, looking at the 5 suggests that we've got to round up, so we go to 17. That's why we went to 17 when we rounded to the nearest pound. And looking at 89 pence, now where is the pound coin represented here? There is no pound coin, so if it was, and if we showed this as or with pound notation, we'd have something like this. So there is a 0 that represents the units or the pound coins, and again, looking on the right, we've got an 8, which suggests that we round up, so that goes to 1. It doesn't stay with 0, so that's why we rounded to 1. And looking at the pound, just £1, here is the pound represented. Looking on the right, it's a 0, so we're staying down, so this is rounded to £1 as well. In this video, we'll learn to read, measure and record time using AM and PM. So the first thing to do is to clarify what AM and PM mean. AM means ante-meridiem, which is before noon. PM means post-meridiem, after noon. So noon, that is 12 o'clock, and we're talking about 12 at lunchtime, not 12 at midnight, so 12 midday. 12 midday, that is 12 p.m. That's when we start saying p.m. at 12 midday. Then anything after that will be p.m. So 1 p.m., 2 p.m., 3 p.m., 4 p.m. in the afternoon, that is. So we continue 5, 6, 7, 8, 9, 10 till 11 p.m. That 12 there, 12 midnight, that is 12 a.m. Then the one that follows, that's 1 o'clock in the morning, that is a.m. still. So 2 a.m., 3 a.m., 4 a.m. in the morning, 5 a.m. until, again, 11 a.m. After that, that would be going back to 12 p.m. So that's in terms of the full hours, but you still could have 11:59 a.m. and similarly you could have 11:59 p.m. before you move to 12 a.m. The clock face doesn't tell you anything whether it's a.m. or p.m. It only tells you the time. So 1 o'clock, for example, that's going to look like this, whether it's 1 a.m. or 1 p.m. What helps in everyday life? Of course, it's the daylight and it's the darkness at night. But in terms of the questions in the exam, it will be the question telling you, saying something like it's morning or afternoon or evening, and that will help you decide whether it's AM or PM. So when it's 1 AM, again 100 in terms of the 24-hour format. 2 AM 0200, 3 AM 0300, and so on. So this continues with 4 AM, 5 AM, 6 AM, 7 AM, 8 AM, 9 AM, 10 AM, 11 AM, and then we have 12 PM, because that's the point when it changes, so 12 midday, and we still write this as 1200. When it comes to then 1 PM, that is 13, so we add in 1 hour, just like we've been doing throughout. So 11, 12, 13. It's like 12 and 1, that gives you 13. When it's 2 PM, that is 1400. So we add in 2 to the 12, which is the cutoff point. 12 midday. 12 and the 2 gives us 14. When it's 5 PM, so 12 and the 5, that gives us 17. When it's 7 PM, 12 and the 7, that is 19. And the pattern continues like this. So when it's 11 PM, for example, 12 and the 11, that is 23. Similarly, if you want to convert from the 24-hour format into the 12-hour format, looking at these after 12, so 13, if you take away 12, that gives you 1, so it's 1 PM. 17, take away 12 gives you 5, so it's 5 PM. 14, take away 12 gives you 2 PM. 23, take away 12 gives you 11 PM. So that's the way to convert them. So let's try a few more. So if this is the time given to you in the 24-hour format and you need to convert it into the 12-hour format, so using AM and PM, then you need to look at the hours. So that is 14. Again, take away 12, that gives us 2. So it's 2 something. So 2:45. We don't change the minutes. Then looking at this one, we've got 18, take away 12, that gives us 6. So 6:30. 20, take away 12 gives us 8. So 8:15. Okay. And as you can see, they passed 12, all of these, so they are PM ones. Okay, 21, take away the 12, that gives us 9. So 9:22 PM. 22, take away 12 gives us 10. So 10:46 PM. If you're given 11:15, for example, that's below 12, so you know it's AM. So you can just rewrite it as that, just adding 8. So if we're given the 12-hour format, how do we convert them into the 24-hour format? So 6:28 a.m. That is in the morning, so we don't need to add 12. So 06:28. No AM or PM to be added. And as you notice, I put a 0 in front to mean that it's 24 hours that we're talking about. It's a typical thing we use when we do the 24-hour format, but not when we do the 12-hour format. Now we've got 2:45 p.m. So that's in the afternoon. So we need to add 12 to that. So 12 and 2, that is 14. And we keep the minutes unchanged. 6:30 p.m. again in the afternoon. So 6 and 12, that is 18. So put in the minutes there as well. 8:15 p.m. So 8 and 12, that is 20. So 20, 15. Again, 9:22 p.m. So 9 and 12, that is 21. Keeping the minutes unchanged. So 10:46 p.m. That's again in the afternoon. So 10 and the 12, that is 22:46. 11:15 a.m. Now that's in the morning, so we don't need to add 12. I can't put a 0 in front because 11 has 2 digits, so I'm just going to rewrite it as 11:15. Don't need to add AM or PM because we know what that means. So if we're given a clock face to read the time, so looking at the hours, the shorthand, we've got this between 2 and 3. If it's past 2, it means it's 2 something. So not yet 3, but it's 2 something. So that is 2, and then we've got, in terms of minutes, 5, 10, 15, 20, 25. So 2:25, and you need to be given whether it's morning or afternoon in the question. And I've given you morning here. So 2:25 a.m. you'd write. So reading the time, looking at the shorthand, is at 5, but it hasn't reached 12, the minutes hand yet. So that tells me that it's not yet 5 o'clock. So it is 4:55 or 5 to 5. So I'm going to write this as 4:55, and as it's given that it's in the morning, that will be AM. Now same time, if I'm given that it's in the afternoon, all I'll change is to PM. So AM to PM. If I'm given this time, so that's near 7 but not 7 yet. So it's 6 something. 6:45. And if it's in the afternoon or evening, that would be PM. In this video, we'll learn to read time from analog and 24-hour digital clocks. 24-hour digital clocks. We know that digital clocks look like this. So they show time in digits, not like the analog clocks. So when we looked at the 12-hour one, we had AM and PM. So AM for the morning and PM for the afternoon. And I've got the examples here from the previous video. So they're given in AM and PM. Next to these, I'll do the 24-hour digital clocks, because these, the 24-hour format, we don't use AM or PM. Why? As we said, that 24 hours in a full day, and with AM and PM, we needed to use them because we'd get from 12 at night up to 12 midday, there would be 12 hours, and then we'd start again at this point. So that 2 full circles, so we needed to differentiate between them two. Which one is in the morning, which one is in the afternoon? Because just by looking at this clock, do you know whether it's 12 midday or 12 midnight? So you wouldn't know, and that's why we add AM and PM to make the difference clear between the morning and the afternoon. Whereas with 24-hour digital clocks, we continue from that point up to 12 midday, and then we continue with 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and we come full circle at 12 midnight again. So we'll show what that means. So when it's 12 AM or 12 midnight, how do we actually show that in the 24-hour format? So this is the 12-hour format with AM and PM, and here I'll do the 24-hour format, which doesn't have AM or PM. We just increase the numbers. So 12 at midnight is shown like this in the 12-hour format. In the 24-hour format is shown as 0000. So that's the start of the day, of the new day, midnight, and that is what it means. I don't need AM or PM, as I said before. Now 12:10 or 10 past 12, we show it as 0010. That 00 in there suggests that it's early days, early hours of the new day. And then 1 AM, 0100. It means the same thing. Then we go to 8 AM, 8 in the morning. That is shown as 0800. So the clue is there with that 0, really. If you have that 0 in front and you haven't got AM or PM, it's a 24-hour clock. And it's through this that you learn that it's actually 8, because 8 in the evening will be shown slightly different with bigger number at the front. So then we've got 12 PM, which is 12 midday. How do we show that in the 24-hour? Because there is only one 12:00, and that's 12 midday. And then 3:25. Right, at 12, this is what happens after we've gone through all this, and it's 12 midday. We continue. So 5 past 12, 10 past 12, and so on. And it's 13 now. So 1 hour past 12 is actually 13. So then it would be 14, 15. So that is 3, 15:25. And I don't need to write that it is PM because we've gone past 12 midday and it's more than 3 hours past midday. So I don't need that. And then we go to 6:35. Right, so after 12 we said we continue to count, so it's 6 hours after 12. So that's going to be 12 and 6 gives me 18:35. That is 6:35 p.m. And again 8 o'clock, so 8 hours after 12 in the afternoon. So we go 12 and 8 is 20. So we'll go 20:45, and that's what it is. So what is the maximum this can go? And that time is 23:59. So that's 11:59 p.m. 11:59 p.m. It's in the 12-hour format. 1 minute after and you get 12 a.m. so you start again. And whereas with this, 1 minute after you start with 0, 0. So there isn't a 24 effectively. You start with 0, 0. Let's have a look at and give a go converting between the two different formats. So we've got the 12-hour format and the 24-hour one. We've got 3:30 p.m. We'll try and convert that to the 24-hour format. So what we said was different. We would have no AM or PM, and we would work out, if it's in the afternoon, we continue counting from 12. So 1 p.m. would be 13, 2 p.m. would be 14, 3 p.m. would be 15. So 12 at the 3, that's all you need to do. So if you reach that point where you are at 12 midday, and what is going to happen to get to 3? So you just add in 3. When you read PM, add those hours on top of the 12. So 12 at 3 is 15. 15:30, so the minutes won't change, and I don't need to write PM because 15 tells me it's 3 hours past that 12 midday. And what about this 12 p.m? How do I write that in the 24-hour clock? So 12 p.m. was that when we reach 12 noon or 12 midday, and we write it in exactly the same way. We don't need to add any hours or take away any hours. 12:00. And how about 22:15? Now, just by looking at that, it's a larger number than 12, so it's got to be in the afternoon or evening. So how many hours past that? Before I added the numbers on top of 12, now I'm going to take away the 12 to see how many hours past that 12 midday it has been. So 22 take away 12 leaves me with 10. And it's 15 past, and of course it's the afternoon. And what is this? 0000. That's the start of a new day. So it must be 12 a.m. So have a look at converting some hours at home. So read the time, and if you've got in the 12-hour format, change it to the 24-hour format. Or if you've got in the 24-hour format, try working out what it is in the 12-hour format. In this video, we'll learn to read and use symbol scales to the nearest unlabeled division. If you can't remember how to read and use scales to the nearest label division, please check the entry 2 video on this. What is unlabeled division? 0 and 200, 400, 600 and so on, 0, 8, 1, 8, 2. These are the labeled divisions because we can see numbers next to them. They've been labeled. Whereas these smaller divisions in between these numbers, they're not labeled. So we're not being told exactly how many grams or ounces these are. We've got to work out ourselves. So 0 and 200. There is a line between them. Which is slightly longer. So that must be 100 because 100 is halfway between 0 and 200. Then halfway between these two, between 0 and 100, must be 50. So this line in the middle, right in between them two, is 50. Now the line between them two must be halfway through, so it is 25. That keeps moving, so it's a bit hard to show. So this is 25. Then another 25 makes 50, another 25 makes 75, another 25 makes 100. So this is 100, 125, 150, 175, 200. So that shows exactly how many grams in each division. So 25 in each small division. So if I asked, what does this measure? Then we learned there are 25 in each division. There are 2 divisions after 200, so that makes me 50. 250, that is how we read this, 250. How about this? So we've got 200 already and 100 over there, so it makes 300, and the 25, 325 is here. In terms of the ounces, because we looked at the grams in the outside, ounces are the inside. So we've got 0 to 8 ounces. Now as you can see, there are 8 small divisions between them, so that would be 1, 2, 3, 4, 6, 7, 8. So this doesn't need much working out because you can go, right, this is 1, 2, 3 ounces. This is 5 ounces. This is 8, 10, 12, and so on. So in terms of the scale, that's how you decide. Now I've got syringe, which we measure how much liquid in, measure the capacity. Right, so the capacity of this is 60 milliliters. How much water do I have at the moment? So as you can see, that is very close to 50. So 50 would be the label division, but I can see another smaller division that this is closer to. So with unlabeled division, I need to find out. So at this level, I'm expected to know exactly what that is. So between 50 and 60, how many divisions do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we've got a 55 here in the middle. So this must be 51, 52, 53, 54, 55. So this is closer to 51. So that is 51 milliliters. Let's have a look at measuring this. Measuring the width. So now, if we have a look at this, this is not exactly 6 centimeters. It's closer to the division just before it. So to what must it be? We've got 5 centimeters here and we've got 6 centimeters here. And we've got 10 small divisions, as we know already, in between them. So this is closer to the 0.9, so this must be 5.9, because we've got 5.1, 2, 3, 4, 5, 6, 7, 8, and this is closer to 5.9. In terms of a thermometer, let's have a look what would be this temperature here. So we've got 30 and 40, we've got 31, 32, 33, 34, 35, 36, 37, 38, 39, and then 40. So this one here must be 33. Another way to find out is between 30 and 40 is 35. So we've got 5 small divisions, and that must represent each 1 degree. So we'd go 31, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, which makes 14 there. And what about this? So this would be 31, 42 degrees. That's 42 degrees Celsius. And in a clock as well, we've said we go up in 5. So we can see that this is past the 1, which means 5 minutes past. But as you can see, we've got some other divisions as well. So I'll try and read it accurately. So that's 5 minutes. This must be 6, and this is 7, and this is what this is closer to. So 7 minutes past 12. If we had to round this to the nearest 5 minutes, then this is definitely closer to the 1 than to the 2. So we can say 5 past, that is what is rounded to. So what did it mean? To read and use symbol scales to the nearest unlabeled division, you didn't need to round it to the number that were given. Which one was it closer to? To the nearest 5 minutes maybe, to the nearest 5 degrees Celsius, to the nearest centimeter. But what you needed to do is to find out accurately, more accurately, what the measurement is. So that means going into the unlabeled divisions and figuring out how much does each of them represent. Where are we stopping? And that would be the measurement to the nearest unlabeled division. In this video we'll learn to compare measures of length: millimeters, meters, centimeters and kilometers. In order for us to compare them, I'm going to try and put them in order. So we'll pick the smallest one. As we've said, a millimeter is roughly the width of a fingernail. A meter is about the length or the distance from the tip of the fingers of your hand to the shoulder of the other arm on the other side. And a centimeter is about the width of the finger. Kilometer is what we measure distance in, so it's much larger. It's distance from between one place and another. So that's got to be the biggest unit, kilometer. And of course the smallest one is millimeter, because we said it's the width of the fingernail. And centimeter was about the width of the finger, so that must come after the millimeters. And then we have meters, because a meter, as we said, was the distance between the tip of your fingers to the shoulder on the other side. So if you need to recap these, we've got the intro to a video on measures of length. So we've put these in order from the smallest to the biggest, and I'll rewrite these in a row. So we'll try and recap how many in each of them. So how many millimeters would make a centimeter? And a ruler comes in handy here as well. So the small divisions, there are 10 of them in 1 centimeter. So there are 10 millimeters which make 1 centimeter. And how many centimeters would make a meter? You said like a centi is like century, so there are 100 of them, like 100 years in a century, so there are 100 of these that make a meter. And from the meter to the kilometers, there we said K stands for 1,000 in real life. Like I've got 2K followers, that means 2,000. So we're saying there are 1,000 meters in a kilometer. So this should help us with the rest. So we'll try and compare now. Let's say one item measures 7 millimeters, that's the length, and another one is 1 centimeter. So which one is going to be bigger, 7 millimeters or 1 centimeter? Now we said that we need 10 millimeters, the small divisions, there are 10 of those that make 1 centimeter. So we haven't quite reached 10, so this must be smaller than a centimeter. So I'm going to say 7 millimeters are smaller than 1 centimeter. But if we have, let's say, 15 millimeters comparing to 1 centimeter, what would that be? Now that's more than 10 millimeters, so it's somewhere here. So that's definitely more than 1 centimeter. So 15 millimeters are greater than 1 centimeter. Let's try and compare some other ones. Now let's say we've got 53 centimeters, trying to compare them to 1 meter. And we've said that we need 100 century, we need 100 to make a meter, so this is less than that, so I'll write it this way. But if we have 148 centimeters, for instance, that is more than 100, so it is more than 1 meter. And if we have, let's say, 5 meters, the length of the classroom is 5 meters, and we're trying to compare it to a kilometer. Actually, we need 1,000 meters to make a kilometer, so that's much smaller, so we'll put the smaller than sign in there. And if we have, let's say, 1,005 meters, so the length of a stadium is 1,005 meters, and we compare it to 1 kilometer, that is bigger than because it's 5 more than 1,000. So I hope this helps you compare measures of length. In this video we'll compare measures of weight. The two units that we'll focus on are kilogram and gram. We've looked at these before at entry 2, so if you need to revisit these units and know what they look like, then by all means go and check the entry 2 video first. Now, in order for us to compare these measures, I'd like to put them in order so that we know which one is bigger and which one is smaller. We've said when we measured before that there are 1,000 grams in a kilogram. So a gram is much smaller, and we measure in grams tiny amounts like salt or sugar. Maybe we've said also that 2 paracetamol tablets make 1 gram. So it's pretty much a small amount in comparison to a bag of sugar, which weighs a kilogram normally. So I'll put grams first and then kilograms. And as we said, the K tells us that there are 1,000, just like we said 1K, this cost me 1K, this cost me 2K. It tells us that 1,000 grams. So this is the same as saying replacing that K with 1,000 and the G after, so 1,000 grams. So 1,000 grams make 1 kilogram. So we'll try and compare 2 different measures now. Let's say if I weigh something and it is 45 grams, is that bigger or smaller than 1 kilogram? Now, we said we need 1,000 grams to make a kilogram, and this is much less than that. So that suggests that 45 grams is smaller than 1 kilogram. But if we weigh something and the unit is grams, and let's say it weighs 1,520 grams, then that's definitely more than 1,000 grams. So that is more than 1 kilogram as well. In this video, we'll compare measures of capacity. So the 2 units that we'll focus on are liters and milliliters. We went through these 2 units in a previous video at entry 2 as well, which focuses on capacity. So if you've forgotten, revisit that. Now we'll try and put these in order so that it helps us with comparison. Which one is smaller? A liter, that's normally the capacity of a bottle of water or any other drink, and milliliter is what we measure medicine normally in, so it's very small amount. So milliliter would be the smaller amount and liter is the bigger one. How many milliliters would we need to make a liter? And as we said, since it's a very small amount, we won't need 10 of them, we won't need 100, but we'll need 1,000, so many more to make a liter. And the numbers that we deal with when it comes to metric measures are 10, 100 and 1,000. So that tells us that we need 1,000 milliliters to make a liter. Now let's try and compare 2 different measures. Let's say I've measured some liquid and it is 45 milliliters. Probably that's how much I need to put in a cake, maybe 45 milliliters of oil. So we need to compare that to a liter. How does that compare to it? And since we need 1,000 milliliters to make a liter, this is much smaller than 1,000. So that suggests that it is smaller than a liter as well. And if I measure the capacity of a bottle and you need 1,500 milliliters to fill it, comparison to 1 liter, that is going to be greater than, because we just need 1,000 and we've got more than, so we've got 1.5 liters here. So I'll say that is greater than a liter. In this video, we'll learn to use a suitable instrument to measure mass and length. Mass, in a very simplified way, means weight. So we're measuring the weight of different items. In the previous videos, we'll look at how I measured the weight of pasta, a bag of pasta, using a kitchen scale. So a kitchen scale is a suitable instrument to measure the weight of different items, let's say can of baked beans, or maybe the flour, sugar, whatever ingredients you're gonna be using. However, this goes up to a certain amount, and each scale has its maximum. So this says 5,000 grams, which is 5 kilograms. So what we do with maybe larger amounts, then with the larger amounts you're probably looking at bigger scales. We've got bathroom scales, there are probably luggage scales as well. So there are different ones that you can use. Or when it comes to much smaller items, such as measuring gold, for instance, or measuring medicine, there are other scales like precision scales like these. So those would be the right ones to use when it comes to measuring weight. When it comes to length, again, if you're measuring the length of a short line, then you'd use a ruler, but this goes only up to 30 centimeters, and in that case then you'd use a measuring tape, a steel measuring tape, or one of these ones. There are for larger distances, then we'd have to use a real measure tape. So these are the kind of instruments that you'd be using when it comes to measuring weight and length. In this video we'll learn to sort 2D shapes using properties such as line of symmetry. So we'll have a look at how many lines of symmetry each of these shapes have, and we'll try and sort them based on that. So we've got a square here, so all sides are equal. Let's have a look at how many lines of symmetry a square would have. So a line of symmetry cuts the shape into two identical halves. So we've got this, and the length is 40 millimeters. So if I cut the shape here, I can see two identical halves both sides. So that is one line of symmetry. Another line of symmetry would go this way. So right halfway in the middle, measuring them, that would give a line of symmetry. So this has two so far. Now, if I cut this shape diagonally like this, I could create two other halves. So that is another line of symmetry. And finally, there is this line of symmetry. So in total, a square has 4 lines of symmetry. Let's have a look at a rectangle. Now, similar to the square, you can have one going down like this. So that is vertically, and another line horizontally. Can I do this? If I try and put this over, one corner will come to that point. So I'll show what I mean by that. So if I try and fold this shape, that's halfway through, as you can see, these two corners do not match. So I haven't got a line of symmetry here. This is not a line of symmetry for a rectangle, so that does not work. And the same thing would happen if I did that this way. So a rectangle has 2 lines of symmetry. Now we have different types of triangles. This is just one of them. this one, let's see. This one has these two sides the same. So, and these corners of course are the same. So I can cut through in the middle like this, and that would be one line of symmetry. However, I cannot do this here or there because the sides are not equal and the angles are not equal throughout. If we had a triangle that has same size of angles and same size of sides, then what we could do is we cut it this way, and this way to make 3 lines of symmetry. And there are some other triangles as well, such as this one, for example. So none of the sides are the same and none of the angles created are the same. And obviously there would be no line of symmetry for this, because there is no line we could draw that actually cuts the shape into 2 identical ones. And this had 3 and this had 1. Now, if you're interested in names of these triangles, we've got the one with equal sides, so we call that equilateral, and we've got with 2 equal sides, that is called isosceles, and we've got the scalene, which has completely different sizes of sides and angles. Now we'll look at a pentagon and a hexagon. As you can see with the pentagon, it is very clear that we can draw this line of symmetry. These two would be completely identical, but I could also do the same here, and these would be identical. I could do it again here, and these 2 sides would be identical, and I could do it here and here. So there are 5 lines of symmetry for a pentagon, a regular pentagon, one that has equal sides and angles. And a hexagon, do you think it's going to be 6 for it? Let's have a look. So we could draw this line, we could draw this, so we've got 3 already. Could I do this so the 2 sides are actually identical, and they are? Could I do this? And could I do this? So how many lines did I draw in total? Obviously make sure we don't double count them. So I'd say there's 1, 2, 3, 4, 5, 6. That's 6, because then if you do this, that's marked, this is marked, and so on. So there are 6 lines of symmetry for the regular hexagon. So how can we sort now these based on the lines of symmetry? Which ones have 4? And that's only the square. And a rectangle has 2, which is the same as the equilateral triangle. So you can see a pattern in there. And there is 1 and 0, 5 and 6. So what I could say is I want to sort these into shapes that have 3 or less lines of symmetry. So 3 is included, and less, 0 is less, 1 is less, and 2 is less. So I could separate these. So this would be 3 or less. And 4 or more, which includes the square, pentagon and hexagon. So I'll say 4 or more lines of symmetry. But you could be asked to find the lines of symmetry of shapes. You could be asked to draw lines of symmetry. You could be asked to maybe find the shapes that have just 1 lines of symmetry. So these are just some questions. In this video, we'll learn to sort 2D shapes using properties such as angles. So what we'll focus on is to see whether these shapes have right angles, are they smaller than right angles or bigger than right angles. So I've got a square, rectangle, 4 different types of triangles, pentagon and hexagon. So instead of measuring the angles, I will go and compare them to the corners of this piece of paper, because pieces of paper have right angles in their corners. It's 90-degree angles. And that same thing happens with corners of a room or different items such as desks, normally whiteboards. So I will just take the piece of paper and put it on top of the shape to see whether it's a right angle or not. So if I place this on top of the square, I can see that the sides line up with the sides of the paper, and that is a right angle. Of course, this is right angle, this and the other one as well. So this square and all squares are made of right angles. And for the rectangle as well, the same thing happens. So we get 4 right angles. When we look at this triangle, which is the one with the 2 sides that are the same, isosceles, so I'll try and place it on top, and as you can see that one of the sides has just disappeared, to suggest that the corner is actually smaller than 90 degrees. And the same thing happens on the other one and on the other angle as well. So this has smaller than 90-degree angles. Now we'll look at this, which is an equilateral one. It means it has all the angles equal and all the sides equal. If I try to place it again, one of the sides has just disappeared. The same thing here and the same thing on the other one. So obviously these are smaller as well, smaller than 90 degrees. And if I look at this scalene one, look at that. So I can see both of the sides, but they're not in line with the sides of the paper that I'm holding. So that means that this is a bigger than 90-degree angle. Now this one is smaller and this one is smaller. So this has smaller and bigger than 90-degree angles. And this one is called a right angle triangle, which suggests that there is a right angle here. So we've got one right angle and the other ones are smaller, so and smaller. What about a pentagon? Let's have a look. So there is bigger, bigger, bigger. So all of them are the same, so they must be bigger than right angle. How about the hexagon? Again, that's bigger, so all of them will be bigger. So that's bigger than a right angle. Now, the square has right angles, the rectangle has right angles, and the right angle triangle. So if I try and sort them, as you can see, I've ticked on them as well. That means that I've got these shapes with right angle triangles, right angles. So right angle triangle, rectangle and squares all have right angles. That's why I've grouped them together. Whereas we've got some smaller and bigger as well. So if you wanted to sort these as well, we could group them into smaller. So this shape, that, and this one has both actually. So you could group it in both of them. And this one has bigger than a right angle. So this shows how to sort the 2D shapes using angles. In this video, we'll learn to sort 3D shapes using properties. We've looked at the properties of 3D shapes in a video at entry 2. Now, we looked at that time at the base, we looked at the number of faces, vertices, so we could use any of those to sort these shapes. So, or number of corners, for example. So how many corners does a shape have? And if we recall, we had 1, 2, 3, 4, 5, 6, 7, 8. So 8 corners in this shape, 8 in this one. There were 5 in a square-based pyramid, and there were no corners in these two. So we could say this group no corners or 0 corners, and this would be with 5 corners and 8 corners. So we've just sorted these 3D shapes based on the number of corners, but we could sort them in other ways as well, and that's what we're going to try and do. So let's think of the number of faces, maybe. So in terms of the number of faces, we said there was 1, 2, 3, 4, 5, 6 faces in this one, and there were 6 faces in the rectangle as well. So these would be grouped together with 6 faces, and there were 5 faces in the square-based pyramid, and there would be 3 faces, we said, for a cylinder, and 1 face for the sphere. So 1, 3, 5 and 6. So different ones. But we could also sort these in terms of the shape of the base. So we looked at it before and we saw that the base of a cube is a square, but also in the square-based pyramid the base is a square. So they would go together, and this is a rectangle, so that will be different. This has a circular base and this has no base at all, so we could sort these. Yep. So let's say rectangular, circular, no base, and square base. You could sort these by their length, you could sort them by the edges, the number of edges. So there are different ways you could sort 3D shapes. These are just some examples. In this video, we'll learn to use appropriate positional vocabulary to describe position and direction, especially the 8 compass points. What do I mean by that? You've probably used a compass point in your life, and there are usually 4 compass points, but sometimes even 8, and I'll show what these mean. As you can see, one of these points shows an arrow, and that is the north, so going up the north, just like the north that you've shown in questions as well. So an arrow going upwards towards the top of the paper, marked as N to mean north. So that arrow is represented through this arrow, green arrow here. So that means north. Now at the bottom we've got south. So completely the opposite of north, we've got south. So if I continued here, that would be south here. And on the right, we've got an E, which means east. So this way is east, and completely on the opposite of east is the west on the left. So what are the other 4 points? So we've got 4 points already. What are the other 4 points? The other 4 points stands in between these 4. So between north and west is the northwest. Between north and east is the northeast. Between south and east is the southeast, and between south and west is the southwest. So what we're saying first is whether it's north or south, and then either east or west. So north, east, northwest, southeast, southwest. So first of all, you start with showing north, and then completely the opposite is south. Then on the right is east, on the left is west, and you can fill those in between by starting with north or south and then giving east or west. Let's have a look at what this means exactly. So I've got the UK map here, and what I'm going to be doing is looking at the direction of different cities from different ones. So we'll start with Manchester, and I will draw north from Manchester. So there is north. So that's always a starting point, looking at the direction of north, doing something that is parallel to that. I like to refer to the top of the paper by making a right angle triangle. So there is north, and we have south. On the right we've got east and west on the left. Now Leeds, where is Leeds? Leeds is northeast of Manchester. As you can see, so there is north, there is east. This is northeast of Manchester. And let's have a look at some other places. We have London here. And so here is north, and here is south. So what do we see? What do we notice? Which city is north of London? That is Cambridge. Which city is south of London? That is Brighton. And that is the west. So Oxford is more or less west of London, and so is Bristol. So that just gives us some examples of how to use the compass points to describe position and direction. So we would say Leeds is northeast of Manchester, so you need to move due northeast from Manchester to get to Leeds. What about from Leeds? So there is Leeds, there is the north, there is the south, there is the east, and that's the west. So Manchester is southwest of Leeds. So there is the south, there is the west. So between the south and the west of Leeds, so Manchester is southwest of Leeds. Now we look at turns. So if we face in north and we move a full turn in the clockwise direction, we'd end up north again. So same thing, if I was facing north and then did a full turn in the anti-clockwise direction, I would end up north as well. So wherever you start, you'd end up with again if you did a full turn. So if you started in the east, do a full turn, and you'd get to the east again, facing east again. So if we do a full turn, we end up where we started. Now half turn again. Let's say we're facing west, and we're doing a half turn, which is half a circle. When we say half a turn, half a circle. Full turn was a full circle. So I'll end up in the opposite direction here. So starting west, and I'll make a half turn, so I'm ending up in the east. So whatever is in the opposite, that's what it means, half turn. So this was in the clockwise direction because that's how the clock moves. The minutes will go through this journey, not this way. So this is clockwise and this is anti-clockwise. So if I do this now anti-clockwise, again with a half turn, it brings me to the same place. What happens with a quarter turn? Let's say I'm north, I'm doing a quarter turn in the clockwise direction. So quarter, there is a quarter. So I've ended up in the east. Another quarter turn in the clockwise direction, and I am in the south. Another quarter turn and I'm in the west, and another quarter turn clockwise and I'm in the north. This then would be a quarter turn anti-clockwise to go to the west, and then south, another quarter turn anti-clockwise to the east, another one to the north. Let's suppose we're starting in the northwest and we're doing a quarter turn. So northwest, quarter turn will bring me to southwest, and if now I make a move anti-clockwise, sorry, I'll make now a move clockwise because the previous one was anti-clockwise, so I'll go clockwise to the northwest, quarter turn, clockwise again, quarter turn to the northeast, another move, and I go to the southeast. So things to remember about full turns. Full turn is a full circle, and it didn't matter whether we go clockwise or anti-clockwise because you're going to end up in the same place or facing the same direction. And if we do half turns, it's half a circle. So again, it did not matter in this case whether we're doing it clockwise or anti-clockwise because the place you ended up with or in is the same. So from the north you're going to get to the south, from the north you're going to get to the south. So it did not matter in half turn as well. When it came to quarter turn, it does matter. So quarter is like quarter of a pizza again, quarter turn, a quarter of a circle. So from the north, if I move quarter turn clockwise, I'll end up in the east. If I move quarter turn from the north anti-clockwise, I'll end up in the west. So that really matters whether you go clockwise or anti-clockwise. So now going to the example of the cities we had. So if we are in London, facing north, we'd face Cambridge. But if we make a half turn clockwise or anti-clockwise, we'd be facing Brighton. So again, let's try it anti-clockwise and it will get to Brighton again. So facing Brighton. And if you make from Brighton a quarter turn anti-clockwise, then we face in Bristol. In this video we'll learn to extract information from frequency tables. At entry 3 you're expected to know how to extract information from lists, tables, diagrams and frequency tables. At entry 2, I've gone through how to do that with lists, tables, diagrams. So what I'll focus on in this video is frequency tables. Now, frequency tables are things that you probably have come across before, and they look very similar to tally charts. And I'll show how. So I have a number of cubes in my tin. What I want to do is I'll show the colors, the different colors, and how many of each color there are in a frequency table. So I'll start with colors. So we've got pink ones. So I'll write pink. We've got brown, got white, and we've got black. If I had more colours, I'd include those as well. So if you're talking about maybe types of fruit or vegetable or types of food, you'd include each specific type in there, and having a heading is needed as well, is really useful. So we know we're talking about colours. All of these are colours. If it's food, then you put food. If it's all fruit, you write fruit at the top. So we've got the colours. Now next to it, we'll record the tallies, like in a tally chart. So obviously you'd use a ruler in your notebook, but I'm just showing you quickly. So white, there is just one, and I'll put a mark there. And this is the frequency. It means the same thing as the tallies, but you're not using tallies to record it, you're using numbers. So I'll write 1 as the number, digit. And we've got, okay, let's look at the pink. We've done white, look at pink. We've got pink 1, and another 1, and another 1, and another 1. 5th one, we go across. Uh-oh, I mixed them up. So we had 1, 2, 3, 4, 5, 2, 3, 4, 5, and another 2. So 5 and 5, 10, and the 2, 12 all together. Then brown, and black. So brown was 5 and 1, 6. Black is 1, and another 1, another 1, 4th, 5th, 6th, 7th, 8th. So we record these. Now for me it was easy because I separated them into colors first, but I would, if they were mixed up, I would go, right, okay, black, where is black? Go to black and mark 1. Then comes white. Okay, where is white? Mark 1. And that's what normally happens when you go around, for instance, and you want to investigate the favorite food in your class. So one person might say, well, fish and chips is my favorite one, so go to fish and chips and put a tally. and maybe the next one could be pizza. So you go to pizza and you do that. So they don't come in order, just like I had all the pink cubes together. That's what I mean. Now the final thing is to write the total. So I would total. So we've got, let's pair them up, because 12 and 8 we've learned before, it makes 20, so it's number bonds to 20. So we've got 20, 26, 27, easy to count and add. So 27 in total. This is how you actually draw a frequency table. This is how you draw a frequency table. So we'll now extract some information from the frequency table. These are just some examples of the questions that you could be asked. How many brown cubes are there? So we're looking at brown. Where is brown? There are 6 of them. Double checking. How many more black than white cubes are there? So we're comparing black with white. And there we have, there is 1 white and 8 black. How many more are black? And that is 7, because 8 take away 1 gives you 7. 1 and 7 gives you 8. Or you could just go comparing them. There we have white and that's black. So that's the same. Now this is extra, that's extra, and that's extra, and this is extra as well. So counting them, 1, 2, 3, 4, 5, 6, 7. And that confirms what we've just done. How many fewer than pink are brown? So we're looking at pink and brown all together. How many fewer? How many? It's about less. So we've got up to this point, they are the same. Then we have this extra, that extra, that extra. So we've got 1, 2, 3, 4, 5, 6. And again, 12 take away 6 gives me 6. 6 at 6 gives me 12. So there are 6 fewer brown than pink. In this video, we'll make comparisons between line graphs and bar charts. This is a bar chart and this is a line graph. In the line graph, we've shown weather temperature in Birmingham in the first week of March 2019. So we've got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday, and we've shown what the temperature was on those days. And as you can see, you've got temperature being low to begin with at 5 degrees Celsius, going up, remaining the same for 2 days and then going up again. So we've got temperature rising till Thursday, and then we see a drop on Friday to pick up again on Saturday and reach the peak on Sunday with 11 degrees Celsius. So what this line graph is showing us is the trend. How is the temperature changing? It's the same city but different days. So we can see patterns through line graphs. We've got time at the bottom and the line shows the patterns or the changes. Whereas in a bar chart, look at what we do. We've got bars. We haven't got dots that are joined together to show any pattern, but this is to contrast. This is to compare and contrast. So we've got Birmingham, we've got Leeds and London. So the 3 cities. Again, temperature in degrees Celsius, and so it's weather temperature on average in March 2019 in Birmingham, Leeds and London. So what does this show us? Can we join these together? No, we can't, because it's not the same city and we're not showing temperature for the same city, but we're kind of comparing which bar is the highest, which one is the lowest, and so on. So if you compare Birmingham with Leeds, it seems like Birmingham was warmer during March. So London had the hottest temperature in comparison to the 3. Leeds had the coldest temperature. So what we're using the bar charts for is to compare and to contrast, whereas the line graph is more to show the patterns, the changes that have happened during the time. You could also have this being shown in a bar chart, and you can see the height of the bar charts changing to notice the pattern again. However, you cannot put the data that we have in this bar chart into a line graph because there is no continuity. There is not one thing that you want to see how it's changing, like temperature or sales, profit that you've made during a month. In this video, we'll look at organizing and representing information in appropriate ways. Now, at entry 2, we've looked at organizing and creating tables, diagrams, and bar charts. What we'll focus on in this video is simple line graphs. If you need to revisit any of these, go back to the video at entry 2. And what I've got here is a table with days and temperatures in Birmingham in a week. And I'll represent that information in a line graph, and we'll see the changes very clearly from one day to the next. So line graphs are for things that change, and you want to see that pattern in change. Other things that you might show using a line graph include maybe profit made in a business, number of sales, so things that you want to see the pattern of changing at. It's normally time at the bottom. So on the horizontal axis, I will put the days of the week. So we'd have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So here we'll project the temperatures. So temperature in degrees Celsius. So we know it's not Fahrenheit. So we've got now starting from 0, this goes up to 11, so we've got to make sure we include numbers up to 11 here. So we'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And here are days of the week. So for Monday, it's 5 degrees, so we'll go to this point here. So a bit like a bar chart, where you'd put a line through, but here you just put a dot. So Tuesday, it goes to 7. You'd need graph paper to do it properly. And then Wednesday, 7 again. Thursday, it's 8, so it goes up by 1. Friday, 6 degrees. Saturday, 10, and Sunday, 11. So you can see now how the temperature has changed, but we'd join the lines up so that change becomes even clearer. Doesn't have to be perfect, doesn't have to be perfectly lined as well, but you can see the pattern now. So we start with 5 degrees and the temperature increases, stays the same for 2 days, it goes up by 1 degree, and then it drops again to go to 6. It increases again on Saturday to go to 10 degrees, and finally it reaches the peak on Sunday with 11 degrees. So that can clearly show how many degrees and the pattern as well from one day to another. And this of course would need a title, so you tell the person who reads this line graph what this is about. So because you just present this without the table, without the list, so I would go weather, temperature in Birmingham in the first week of March 2019, if that is the case. And of course this title would be on top, but I didn't have the space to include it there, so that's where you should put it, on top, not through the line.